So it's about time, sir. Should we start? Or as you say, should we wait for 2 to 4 minutes? Whatever you say, sir. Sorry, sir, I cannot hear you. Probably it has gone on mute.
Yeah, we'll wait for 2-3 minutes.
Okay, sir. Shall we start, sir?
Yeah, we'll proceed.
So I'll introduce and then we may start with the session, sir.
Yeah, thank you.
A very good morning to all the participants of this AICT sponsored 1 week online short-term training program on water quality complication, restoration, and environmental conservation of existing water bodies, Module 2. So we are on the 6th day of this training program and we have with us Sravanth Tangellamudi, sir. He is working as a scientist in National Institute for Interdisciplinary Science Technology Division, Environmental Technology Division, Thiruvananthapuram, Kerala. He has won prestigious awards like the Pratibha Award for Excellence in BTech by the Honorable Chief Minister of Andhra Pradesh and MHRD Merit Scholar in graduation. With an expertise in environmental engineering, environmental impact assessment, risk assessment, and hazard operability study, he has worked on a number of projects. A few of them are listed here, like environmental impact assessment, environmental management plan study, quantitative risk assessments, hazard operability study for isolated storage and handling of hazardous chemical units, emergency response and disaster management plan for Indian Oil Corporation Limited, LPG bottling plant, Timmapur, Telangana, gap analysis and performance evaluation study for common effluent treatment plant, Ramki Pharmacity India Limited, Visakhapatnam, and a lot number of projects. I could list only a few of them over here. So he will be taking this session on continuous treatability of oily wastewater from locomotive wash facilities by electrocoagulation. I thank you, sir, on behalf of the Civil Engineering Department of IPS Academy, Institute of Engineering and Science, Indore, for accepting an invitation and request and being here with us today. Thank you so much, sir. And I request you please start with the session, sir.
Thank you, ma'am. In the first place, I would like to thank you for inviting me to deliver an expert talk on this AICT sponsored short-term training program on water complication module 2 conducted by the IPS Academy Institute of Engineering and Science Indore. It is my privilege to be a part of this short-term training program today. And to begin with the presentation, I'll just share my screen. Hope my slides are visible, ma'am.
Yes, sir.
Yes. So, as mentioned by Dr. Devanshi ma'am, my expertise belong to environmental impact assessment and risk assessment. But since the theme of this workshop is to water conservation and treatment facilities, so I've chosen this topic on oily wastewater, various conventional treatment methods available, and how electrocoagulation can supersede these conventional treatment methods in an efficient manner, with a case study of treatment of this oily wastewater from locomotive wash facilities by electrocoagulation. So, at this outset, on a general context, environmental pollution is a potential threat to living conditions on Earth, and overpopulation has resulted in overexploitation of natural resources, which led to the increase of pollutions in the environment. Water conservation is one such area which requires a significant attention in recent times. And there are some challenges due to this urbanization, which include the exploding population, scarce resources, the lack of supervision, insufficient infrastructure, unplanned urbanization, and so on. And there are some challenges in urban water and wastewater management, which include the climate change impact and water availability and quality, out of which some of them are the unplanned urban growth, the urban decay, aging of our infrastructure, problems in urban sanitation, and underinvestment in infrastructure. To overcome these challenges, we need to develop a water and wastewater management system in an efficient manner in order to achieve the sustainable development goals. Before going into the details of oily wastewater and its treatment facilities, I want to take you all through some water and wastewater statistics available in the globally available. Out of 359.4 billion cubic meters of wastewater produced each year, it is equivalent to 144 million Olympic sized swimming pools. You can expect the quantum of wastewater being generated all around the globe, and out of which only 11% of the total volume, that is 40 billion cubic meters of wastewater, is being reused, and around 48 percentage, that is roughly around 172 billion cubic meters of wastewater, it is being released into the environment without treatment, either directly or following collection. And this is the slide depicting the wastewater production, collection, treatment, and reuse at a country scale. You can see where India is lying on the wastewater collection and treatment infrastructure. India is producing approximately 10 to 25 cubic meter per capita per year of wastewater, out of which the collection is only 5 to 25 percentage, And out of the collected wastewater, only 5 to 25 percentage is being treated. And you can see the reuse, it's negligible. Less than 5% of our wastewater is being reused. You can see countries like Australia, where they have the collection efficiency and treatment efficiency equivalent to 100%, and they are reusing almost 50% of their treated wastewater. So we need to understand these challenges in the present times, and we need to adopt the recycle and reuse techniques in order to meet the water demands projected in the near future. And this is the household wastewater treatment system, where India is only treating 26 to 50 percentage of wastewater from the households, and countries like United States, Alaska, and Greenland, they are like treating more than 90 percentage of their wastewater from households in an efficient manner. And this is the water demand and supply scenario by 2030 projected at a rate of 2.8 percentage compound annual growth rate. By 2030, you can observe that 1500 billion cubic meters of water demand is projected, whereas the supply is only 700 billion cubic meters. So a 50% of demand supply gap is being observed here. And there is a statement that if India reuses 80% of its untreated wastewater from 110 of its most populous cities, 75% of projected industrial wastewater demand can be met by 2025, which is the near future. The water scarcity challenges are growing, and reusing the treated wastewater provides the most sustainable source of clean water to our future generations. And coming to the oily wastewater, oil is one of the most important hydrocarbon products in this modern world, and along with various metals, non-metals, pollutants and contaminants, oil and grease has contributed largely to water pollution. This is being released into the environment at various stages like production, transportation, refining and use. And the concentration of these oil and grease in the wastewaters, it is varying widely from 1 milligram per liter to as high as 1 lakh milligram per liter based on different wastewater sources. And in the picture you can see the rainbow color effect of the oil surface, where the diesel or petrol is spilled on a road on a rainy day. You can observe that the oil surface reflects light, which this phenomena is called as thin film interference. And the major sources of this oily wastewater include the food and beverage industry, where the restaurants, the meat packaging and food processing industries come, and oil refineries, automobile and locomotive wash facilities, where they do this cleaning and maintenance of these machines, petrochemicals, dairy industries, textile and leather industries, and bilge water. Bilge water is something that comes from the ships, the wastewater from the machinery spaces of the vessel or a ship, which includes the internal drainage systems, the sludge tanks, and various other components. And this is a highly polluted water which is being left out into the aquatic environment. There is also ballast water called, but it is different from bilge water. The ballast water, it is taken on board onto a vessel or a ship to ensure stability by maintaining the low center of gravity. So the bilge water is more contaminated than the ballast water. And so what's the problem with this oil and grease? There are environmental problems, collection system problems, and wastewater treatment problems associated with this oil and grease wastewater. And the environmental problems are its toxicity, suffocation, due to which the aquatic and flora and fauna, they usually damage to the ecology. And also it prevents oxygen transfer into the water, and the aesthetic view of this oil and greasy wastewater is also an environmental problem. And globally, around 15 billion cubic meter of oily wastewater is being generated, which is around 5 to 6% of the total wastewater, which I have projected in the early slides. And this is affecting the surface water and the groundwater resources, endangering the aquatic system and human health. And the biodegradability of this oil and grease in natural ecosystem is very low. And also these oil components, they can block the biological functioning of the natural ecosystem for a long period of time. And this oil and greasy wastewater, it cannot be collected and discharged to the municipal sewers or drainage network directly because of the faulty wastewater treatment system. Sticky in nature, this tends to clog the drain pipes and also the sewer lines and cause corrosion and odor nuisance under anaerobic conditions. As you can see, the major factors that affect the separation of free oil from water include this density, viscosity, droplet size, and temperature, where the Stokes law states that the separation rate is directly proportional to the difference in density of oil and water and also the droplet size, and it is inversely proportional to the viscosity of the surrounding fluid. The lower the viscosity, the higher it will raise in the water, and also the size of oil droplets. The larger the diameter of the oil droplets, the better is the rate of separation. And temperature is yet another factor which is important as it affects the density and viscosity. Lower temperature of water, it hinders the separation of oil due to the additional viscous drag in cold temperature. And oil separation, it is better in warmer temperature, and slightly increasing the temperature of the water would give you the better separation removal. And here you can see the pollutant size classified as suspended solids, colloids, and dissolved components. And most of the oil and greasy wastewater, they lie in this region of colloids and dissolved components. And in the table, you can find the typical hydraulic residence time of a settler for wastewater treatment based on the diameter of particle. It varies. And looking into the characteristics of this oily wastewater, the oil in water, it appears in three manners. First one is the immiscible mixture, second one is the unstable emulsion, and third one is the secondary oil in water emulsion. The first two cases, the separation of oil is very easy and it can be achieved through mechanical or physico-chemical processes like gravity separation, coagulation, and flocculation. But the third, secondary oil in water emulsion, it is very stable due to the presence of surfactants and co-surfactants, and this stability arises from the formation of interfacial films encapsulating the oil droplets. And you can see the typical range of oil and grease in various types of waters and wastewater. Starting with the sewage, it consists of around 10 to 100 milligram per liter of oil and grease. And the primary metal concentrates which have 10,000 to 50,000 milligram per liter of oil and grease. And the highest concentration is found in the metals fabrication industries or units, where up to 1 lakh milligram per liter of oil and grease can be found in the wastewaters generated in that specific units. And these are some of the environmental effects of oily wastewater. On sewer systems, you can find the pipe clogging, odor nuisance, and contamination of soil and water. And on sewage treatment plants, you can find the overloading of the treatment units due to this oil and greasy wastewater, which decreases the efficacy of the treatment unit and the increased operational and maintenance costs. And on water bodies, there is oxygen depletion and mortality of aquatic organisms, contamination of drinking water, and public health issues due to this oil and greasy wastewater. And on soil, you can see the reduced aeration, compromised flora and fauna, the crop production losses due to the degradation of soil quality and loss of nutrients due to this oily wastewater, and which indirectly results to the groundwater contamination. And this is a locomotive wash facility where the India has a largest network of railways, and the water discharging from these locomotive workshops and garages are in large quantities, causing the water pollution. On an average, one car requires 40 to 120 liters of water per wash, depending on the type of facility, whether it is automatic or manual. And one locomotive requires around 200 to 800 liters of water per wash, be it diesel or electric, and also the type of wash station facility. And to clean one entire train, we require 20,000 liters of water. So it is generating a huge quantum of wastewater, particularly this automobile industry. And in general, the automobile industry wastewater, it contains large concentrations of suspended solids and dissolved solids of order 200 to 1600 milligram per liter, and also the COD concentration is varying between 1000 to 2600 milligram per liter. And this oil and grease, it is a measure of various substances including the fuel and also the lubricating oil, hydraulic oil and motor oil in this water. And there are some conventional treatment methods for the treatment of this oil and greasy wastewater, which includes the gravity separation, chemical emulsion break, flotation, coagulation, and flocculation. These methods are very effective in removing the free oil from the water, but they remain ineffective for the removal of smaller oil droplets and emulsions because they have high surface charges, resulting in the stability of oil in water system. And there are some oil water separators, which are the pre-treatment considerations in any effluent treatment plant, which improves the treatability and the chance of recycling, which eliminates the grit, solids and rags. And also there are maintenance considerations, which include the cleaning, sludge and solids removal. There is this API separator called as American Petroleum Institute separator, where the ability of oil water separators to function properly depends upon the timely performance, required service and maintenance. These must be monitored and maintained by competent personnel. Frequent inspections should be made in system and also in associated piping and valves to prevent operational and mechanical failures or inefficiencies. The sludge or oil need to be periodically removed from this oil and water separators to keep it operating properly for achieving higher removal efficiency. And these are oil skimmers you can observe in effluent treatment plants or common effluent treatment plants for removal of free floating oil. And this is the conventional chemical coagulation system where direct dosing of coagulant like alum is fed to the system of this wastewater, and the collision of coagulated colloids is promoted for the formation of larger particles, which is called the flocculation, which is a physical treatment, and then followed by a separation by a settler or a flotation unit. All these conventional methods are not sufficient to ensure the discharge limits because of the variable characteristics of the wastewater and of its low efficiency in removing the light and finely dispersed oil particles. Hence, these conventional processes are ruled out for the requirement of large space and skilled technicians. So this is where electrocoagulation can supersede these conventional treatment methods, and by comparing the electrocoagulation with conventional technologies, you can see that the result, the investment point of view, and also the ease of operation and maintenance is very effective in electrocoagulation than the chemical technologies and the mechanical separation or filtration techniques. And Central Pollution Control Board has specified some discharge standards for this oil and grease wastewater. So if you were to discharge the treated wastewater onto inland surface water or land for irrigation, the standard to be maintained is 10 milligram per liter. And if you were to discharge into the public sewers or marine coastal environment, the standard to be maintained is 20 milligram per liter. And seeing the electrocoagulation, the history of electrocoagulation, it was first patented in the year 1906, and was used to treat the bilge water from the ships. Later on, the electrocoagulation of drinking water was first applied in United States in the year 1946. But because of the relatively high capital investment and expensive electrical supply in those days, this technology did not find wide application. But with ever increasing standards of drinking water and stringent environment laws and regulations regarding the discharge of wastewater, this technology has gained worldwide acceptance and importance in the recent decades. The coagulation accomplished by the in situ generation of the coagulants by electrolytic oxidation of an appropriate anode metal is referred to as electrocoagulation in general, and this can also be called as the electrocoagulation flotation process, where it is accompanied by the flotation process also due to the evolution of hydrogen bubbles from the cathode and the interactions occurring within an ECF process. You can see the flotation and the electrocoagulation interacting with each other, and this technology, it is more effective in treating the wastewater containing small and light suspended particles because of the accompanying electroflotation effect, and it plays a significant role in treatment of oily wastewater because of various advantages it have, like easy operation, equipment, low operating costs, and decreased amount of sludge. And the advancement in the electrocoagulation technology is like it currently being used for elimination of contaminants in water as well as wastewater like colloids. And this groundbreaking technology, it is very effective in removing the suspended solids to submicron levels and oxidizing and removing heavy metals from water without any multiple separation chemicals. And the choice of an appropriate electrode material also plays an important role to ensure the success of any electrochemical process. And the electrochemical process, it acts in three ways. The first one is the ionic charge and the droplet or particle size, and followed by the droplet or particle density to the emulsifiable oil and suspended particles in the wastewater. So this process, it introduces highly charged polymeric metal hydroxide species into the system, which neutralize the electrostatic charges on suspended solids and oil droplets to facilitate the agglomeration or coagulation for a better rate of removal. This process not only provides a faster rate of removal and simplicity of operation, but also it produces less amount of sludge because there is no chemical additive required in this technology. And looking into the electrocoagulation mechanism, there are multiple electrochemical reactions occurring simultaneously at the anode and cathode. You can see the when direct current is applied to the water through a pair of electrodes, the energy barrier is overcome and the water molecules, they get broken down into hydrogen and oxygen gases. The hydrogen bubbles generation is observed at the cathode and oxygen bubbles from the anode. However, if the anode material, it is made of metal which have lower oxidation potentials than water, the anode dissolves to produce metal ions instead of generating this oxygen, and these metal ions interact with the hydroxyl ions to produce metal hydroxides. And the oxygen and hydrogen bubbles generated promotes turbulence and adhesion for soft mixing conditions and improves the flocculation process, which is referred to as electroflocculation, and the density of new species decreases, which promotes the flotation of the particle, which is referred to as electroflotation. And the formation of these metal hydroxides, they result in flocks formation which have larger surface area and are beneficial for rapid absorption of soluble organic compounds and trapping of colloidal particles. And you can see these are the general 6 processes which happen during any electrocoagulation process, where the migration to opposite charged electrode and aggregation due to charge neutralization occurs. a formation of hydroxyl ion and its precipitate along with the pollutant, and the bridge coagulation where the bonding of pollutant occurs due to the coagulation in the form of metal hydroxides, and sweep coagulation where the large lattice like structures formed by these metal hydroxides sweep through the water, and oxidation of pollutants to less toxic species, removal by electroflotation or sedimentation. And there are certain factors which affect this electrochemical or the electrocoagulation process, wherein the first one is the current density or charge density. The amount of aluminum ions released into a system, it is determined by the supply of current to the electrocoagulation system. The value of current needs to be achieved to a critical value. Once this critical value is achieved, there will be no considerable increase in the treatment efficiency or effluent quality. And next to that, it is the pH, which plays an important role. As the pH increase, the stability decrease and the particles aggregate into large settleable flocks, which makes the removal efficient. And then the electrode material. The nature of electrode material influences the selectivity, and also it determines the efficiency of the process of oxidation of the organic material. So the commonly used electrodes are iron and aluminum, where these are the sacrificial metal anodes used in the electrocoagulation process. And applied voltage, it is directly related to the current density, where the coagulant dosage and the bubble generation rates strongly influence both the solution mixing and the mass transfer at the electrodes. And the next one is the electrode distance, where it plays an important role in this electrocoagulation process. Many researchers and studies states that a minimum distance of 2.5 to 3 centimeter is taken as the optimum value of electrode distance, and with increase in the distance, the electric potential between the electrode decreases, and it results in the decrease in the performance of the process. Similarly, for decreasing the distance below 2.5 centimeters, the total resistance between the electrode increases due to less space and accumulation of bubbles generated takes place. Electrolysis time is one of the important factor which affect the electrocoagulation process, where the reaction time determines the rate of production of aluminum ions from the electrodes. The effect of operating time and the result indicated that increase in time of the electrolysis from 10 to 60 minutes yielded a better increase in removal efficiency of COD, oil and grease or turbidity. And if the process is carried out at a time greater than the optimum time, it may lead to decrease in the treatment efficiency because of the restabilization of the colloidal pollutant. Thus, an optimum electrolysis time is of importance in this technology. And you can see the various applications of electrocoagulation to various water and wastewater types with different anode and cathode material like aluminum and iron, and optimum current density and treatment time and pH as the operating variables. You can find that the oil and grease, TSS, turbidity and COD removal efficiencies of more than 95% is being achieved with this technology. And these are some of the advantages of electrochemical technologies, wherein no residue is formed because the main reagent used is the electron itself. And the versatility of this technology is that many processes occur simultaneously in this cell, which helps to increase the efficiency. And the point of use production of chemicals like the hydroxyl metal ions which are generated in this technology, and volumes of fluid from microliters to thousands of cubic meters can be treated using this electrocoagulation. And this process, it works at room temperature and atmospheric pressure, and it is easy to operate and cost effective. This is one case study where the oil and greasy wastewater is collected from the locomotive wash facility of Golden Rock Workshop, Ponmalai, Trichy, situated in Tamil Nadu. And the wastewater has been analyzed for its characteristics, where you can find the pH as 8.64 and also the turbidity as 728 NTU, and the COD it is varying between 3400 to 3800 milligram per liter. And this study was conducted in two phases, where in the first phase the treatment of this water using electrocoagulation, and by optimizing the different operating parameters like current density, temperature, reaction time, and electrode distance. In the phase 2, this was optimized by the COD removal by using the response surface methodology to obtain the maximum removal efficiency of COD. And this is the experimental setup for the continuous electrocoagulation process, where a working volume of 2 liters reactor has been taken, and followed by a 930 cubic meter of sedimentation chamber, and aluminum is used as the anode and cathode, with an electrode spacing of 3 centimeters connected to a DC power supply, and the influent flow rate is maintained at 55 ml per minute, and the effluent was collected every 10 minutes from the outlet of this sedimentation tank and analyzed for the COD removal. You can see the oil and grease scum or froth which is floating on the water over the course of time, and the COD removal efficiency was found to be 89.36 percentage, which was achieved after 60 minutes of reaction time. And since the electrical conductivity of the wastewater itself was high enough to conduct the EC process, no addition of electrolyte solution was needed there. But in case if the raw wastewater does not have much electrical conductivity, then addition of the electrolytes electrolytic solutions like sodium chloride of known concentrations can be considered to obtain the maximum removal efficiencies. And the effect of operating parameters was studied at different operating conditions in order to optimize the operational variables. And you can see the effect of reaction time on COD removal efficiency with respect to time, and it took only 40 minutes to remove the efficiency to achieve a efficiency of 86.77 percentage, and therefore an optimum reaction time of 1 hour or 60 minutes was selected for further experiments. And also after some time during the reaction, the increase in time, excessive ion generation near the electrode leads to passivation on the anode, hence preventing furthermore dissociation of ions from the electrode, and where the maximum removal efficiency is achieved and further no dissociation of ions takes place. And the applied voltage was varied between 15 to 28 volts, and the COD removal efficiency was studied based on the current density, as it could influence the efficiency of this process. The higher current leads to the higher generation of metal ions for coagulation, which results in the greater amount of precipitate for removal of the pollutant. And the effect of electrode on the removal efficiency was studied, where 2 centimeter, 3 centimeter, and 4 centimeter of electrode distance was considered. And when the electrode distance was 4 centimeter, the efficiency of COD removal was 82 percentage, and it increased to 88.89 percentage when the electrode distance was 3 centimeters. With increase in spacing between the electrodes, less interaction between the ions and hydroxyl polymers occurs, due to which the removal efficiency decreases. And you can see the variation of turbidity with time, and also the color removal before and after the electrocoagulation. And also we have measured for the oil and grease removal also. Initially it was 220 milligram per liter, and after treatment the oil and grease was removed to 15 milligram per liter, 15 milligram per liter, and the initial turbidity was 728 Newton turbidity minutes, turbidity units, and also after 60 minutes the turbidity decreased to 55.8 NTU, where you can observe the removal efficiency of 92.3 percentage. And in the first initial short period you can see the destabilization and collection of particles, which is in the shorter period of time for 10 to 20 minutes, and then the second stage includes the precipitation of particles, which takes a longer time, up to 60 minutes. And we have optimized this electrocoagulation using response surface methodology. The box behind design was used and the design expert software version 10. We have considered the three factors: reaction time, applied voltage, and electrode distance in the software. And the input to the software will be the range of our interest in each parameter, and the software generates some 17 or 23 runs based on our range and number of operators, for which we have to conduct the experiments for COD removal, and we have to incorporate this COD removal efficiencies in the response column. And you can see COD removal efficiency of 91.96 percentage was observed when the voltage was maintained at 28 and electrode distance of 3 centimeters for a residence time of 60 minutes. And you can see the predicted versus actual COD removal is almost similar, and it was achieved at the optimized condition. These are the response surface methodology 3D graphs, where you can see at any graph two variables are varied, keeping the third variable as constant. By studying the effect of reaction time, voltage, and electrode distance on the removal of COD. And analysis of variance is another factor in response surface methodology, and we have obtained a p-value of 0.0001, which is lower than 0.01 and indicated that the model is statistically significant. And the response surface methodology helps in optimizing the operating parameters in the electrocoagulation process. And from the output of the study, we have that the maximum removal efficiency of COD was achieved as 91.96 percentage at applied voltage of 28 volts and electrode distance of 3 centimeter, and the turbidity removal efficiency was reached to 92.3 percentage, and the final pH of the wastewater after the treatment was found to be 8.5, which is near to the neutral range, and hence the effluent disposal or recycling is not an issue and an advantage with this electrocoagulation process. And these are some of the emerging applications in environment electrocoagulation, like the leachate treatment, the leachate from the sanitary landfills, the textile and colored wastewaters, the pulp and paper industry wastewater, and the wastewater containing heavy metals. So with this, I want to conclude my session, and if any questions, we may proceed further. Thank you.
Thank you so much, sir. I request the participants to come forward and ask any questions and queries to be answered if you have. So I have a question.
Yes, ma'am.
So how can we apply this technology into larger volumes of wastewater?
This technology into larger volumes. Yeah, we can have a continuous reactor rather than batch reactor. We can take this raw effluent on a larger value, means onto a water bodies like rivers and streams. It is not feasible to apply this electrocoagulation system, but the canals like nalas or the smaller water bodies which have restriction to their area, they can be separated from the usual course of river and remediated using this electrocoagulation technique and can be led back into the water bodies with the removal of heavy metals. And this electrocoagulation is efficient in removal of heavy metals too. And we are in the process of future scope to apply this for the removal of heavy metals.
Sir, are there any specific recommendations for the material that is used for the electrodes?
Yeah, the aluminum was found to be the most efficient electrode for this um, electrocoagulation process. Since iron is causing some color problems and some discrepancies with the removal of flocks in terms of the flock or the growth rate or the froth which is being observed or floating onto the matter. And there is like carbon steel which can be applied where the oil and grease wastewater is of low concentrations, but for higher concentrations aluminum was found to be the best sacrificial anode.
So, like if we incorporate this technology into the sewage treatment plants, then in that case we will have to optimize all the conditions for that particular volume of wastewater.
Yeah, we can optimize the conditions on a laboratory scale where we can achieve the maximum removal efficiency. Like there are many proven technologies to optimize these using response surface methodology and all, and then we can apply these to the sewage water treatment units with the same optimum parameters so that we can achieve the removal efficiencies.
So, the in that case, sir, what would be the cost? If you can just give an idea, that what
The
would be the cost requirements for this particular electrocoagulation?
Yeah, the cost requirements, the operating cost is very less considered to the capital cost. However, if aluminum or something is considered as the anode, the capital cost is also considered less. But the considering the current cost and all, for treating a 20 liter of oil and grease wastewater, it costed us around 15 rupees.
So,
So
15 rupees in one time, one batch.
yeah, in one batch, in one batch.
So that's affordable if we can.
Yeah, yeah.
Sir, we have a question raised by Venkatraman sir. Sir, what is the cost, calculated cost per liter for treated effluent? So right now answer, probably that was the right answer. That
Yes,
it is 15 rupees per 20 liters,
20
right sir?
liters. Yes, yes.
Yes. So any other questions if you have, we would like to have a discussion about this very relevant technology for electrocoagulation that can be used in the wastewater treatment, specifically for treating oily wastewater, because we do not know any other technology that is working as efficient as this electrocoagulation, because that not only supports the environmental problems, because the way it is decomposing, the process that is used in this electrocoagulation is helpful in achieving a level of the water that can be discarded right into the environment without thinking a lot about it.
Yeah, yeah. And also there will be not much more sludge because there is no addition of any chemicals into this process. And the coagulants are generated in situ by the dissolution of anode. There will not be much sludge to be disposed. And the effluent straight away can be discarded into the environment.
So what about the electrodes performance? Do they get like
Yeah, yeah.
how
They
long do they work?
how long? It depends on the concentration of oil and grease in the wastewater, and these aluminum its sacrificial is less than iron, but it works for a quite long time, but we need to replace it as long it gets deteriorated.
So normally, say, what would be the duration for replacement of these electrodes? Definitely, that depends upon the type of
Yeah,
wastewater. But an
type of
estimate
wastewater.
that, say, at least it would work for this much duration of days or months.
Yeah. So we have treated almost 100 liters of this oil and grease wastewater in batches, and the 150 millimeter thickness aluminum electrode. It lasted for around 3 months. Yeah.
So if you have any questions, you can type in the chat box or you can unmute yourself. You're most welcome to have a discussion and your doubts answered. So that was a lovely session, sir. Very interesting technology which you brought forward to us, which can be used in future treatment plants, specifically that are industry based, that can treat a lot of oil problem into the wastewater. So we have a number of industries that is using these oil based products that needs to be treated, and probably in future we will have this unit in a lot of the effluent treatment plants of industries incorporated. See, thank you so much, sir. On behalf of the Civil Engineering Department at IPS Academy, Institute of Engineering and Science, we are highly honored and privileged to have you with us today. Especially thanking you for accepting this short notice and being here with us today.
Yeah, it's my pleasure to attend this workshop and share some knowledge with the audience. And thank you for inviting me and considering me for this short-term training program. Thank you.
So privilege is all ours, and we hope to see you sometime in future again, sir.
Yeah, definitely. I'll be ready to provide.
Thank you, sir.
Yeah.
So that was Sravanth sir from East Kerala, and we will be having the next session in a few minutes. So I hope to see you again at around 11:15. So 15-20 minutes break will be taken, and we are meeting again for the next session for today. And see you later after the break.
Because I have to present.
Yes, sir.
Okay, madam. One second. Can you see my screen, madam?
Yes, sir. It's visible, sir.
Okay, and now?
Yes, sir. Now also it's clear.
Okay. I'm going to open some photographs. Please tell me if you see them. Now?
No, sir. I cannot see any photograph. It's on the presentation first slide.
Okay, okay, okay. I think more actions. Mm, so I have to add this to the presentation tray, I guess. This
Yes, sir.
is
Now I can see a photograph.
no, but I wanted to share my screen. How do we share screen in Microsoft Teams?
So when you open this window of Microsoft Teams, then there is an box just besides the microphone and the camera option.
Yeah. So,
So there's an arrow. Once you click that arrow, then you will get an option just below that that you can share your screen or you
uh,
can window something like that. Two options come. One is the screen
okay.
and the other is a window. So you
So
can
when I
share the
share
screen then.
okay, okay. ठीक है, I got it, madam.
You can also include that computer sound.
Yes, I have done that. Now can you see the photograph?
Yes, sir.
Okay, and what about the PowerPoint slideshow?
Yes, sir. Both are visible.
Okay. This quizzes might be visible. Let me just
Yes,
play
sir.
a video to see if this is going well or not.
नमस्ते ये हमारा MLK वेस्ट मैनेजमेंट की एक टेक्नोलॉजी है जो कि हमने
Can you hear the audio
Yes,
from
sir.
this?
Yes, sir. I can hear the audio as well.
Okay, and the video is clear, madam?
Yes, sir. Absolutely clear.
Okay, let me just play for about 5 seconds and
हमारे मेंटर्स से सीखी है और उसमें हमने खुद से कुछ एडिट्स किए हैं ताकि पानी और बेटर ट्रीटमेंट हो सके और कम से कम स्पेस में एक सीवेज ट्रीटमेंट प्लांट बन सके। ये हमारा ट्रीटमेंट प्लांट है जिसमें टॉयलेट्स का पानी, बाथरूम्स का पानी आके प्योरीफाई होता है। इस ट्रीटमेंट प्लांट की खासियत ये है कि ये सिर्फ एक पंप इस्तेमाल करता है अपने पूरे ट्रीटमेंट के लिए।
ठीक है। This is a YouTube video actually. I have to play this. Let me see, how do I play? Yes. Is the video visible?
Yes, sir. It's visible, sir.
Okay.
नमस्कार, हम हैं
Can you hear the
इंदौर
audio?
में शशांक चौरे जी के फिश फार्म
Yes, sir.
जहाँ पे 60 टन्स का
That's
एक प्लांट लगाया गया है।
It's audible, sir.
Yes, ma'am. I am ready now.
So, shall I introduce you first? And
Sure,
then
ma'am.
maybe start?
Yes. Who are the participants today in the
Sir, right. We have faculties from engineering colleges as well as we have certain field experts as well who are working in this, applying this civil technologies, construction basically.
Okay, how many people are there, ma'am? I can't see this because my screen is sharing.
So we have around 20 participants as of now.
Okay, so that means because we have 20 participants, we can keep it an interactive session, right? I hope
Definitely, sir.
everybody will be because I'm weak at presenting. I'll apologize for this beforehand because I'm a technical
Yeah, no
person and
problem, sir.
I work on the grounds most of the time. Yes. And it would be great
So
if
we just
everybody can participate in this presentation and ask questions at any point of time whenever there is a doubt or something. I would be happy to explain.
we encourage the participants to be interactive and as well as you can ask questions. You can type in the chat box, you can raise your hands. Please, you are welcome.
Okay.
So,
I go back. How do I go back to my screen?
uh,
Uh,
sir,
oh yes. Oh
yes,
yes.
sir.
ठीक है. ठीक है, ma'am.
So, shall I introduce you, sir?
Yes, ma'am. Thank you. Thank you so much.
So, we are on the second session of the sixth day of AICT's sponsored 1 week online short-term training program on water quality complication, restoration, and environmental conservation of existing water bodies, Module 2. We are honored and privileged to have with us Harshit Sharma, sir. He is the managing partner, research and development and execution at MLK Waste Management, Bhopal. He is a graduate in civil engineering from IIT Bombay with extensive research, extensive experience in wastewater treatments, managements, and socio-political domains. He is an entrepreneur with expertise in aerobic and anaerobic treatment systems, volunteer and past curator at Global Shapers Bhopal Hub, volunteer at Narmada Samagra, Made Harvesting Heavens, rooftop rainwater filters, and Riva, which is a low-cost drinking water filter with local materials for villages. He is an expertise. He has a lot of field experience in water treatment solutions like natural ETPs for hospitals, domestic industrial effluent treatment plants, hotels and restaurants, lake and pond restoration, fecal sludge management, recirculating aquaculture systems, and aquaponics. We are glad to have you with us today, sir. And on behalf of the Civil Engineering Department at IPS Academy, I am thankful and privileged that you accepted our request and invitation, sir.
Thank
Thank
you,
you
ma'am.
so much, and I request you to please start the session, sir.
Okay. Thank you, madam, to invite me, and I'm glad to be here to share my experiences as a wastewater treatment professional and the current scenarios of wastewater treatment in India. Let me start this session by taking a small quiz, and it would be great if people can speak up. Do you know, does the audience know what is the percentage of households in India that has a household toilet? If anybody can speak up.
You can take a guess, you can type in the chat box.
Ma'am, please help me if somebody is replying because my screen is open here.
Yes, sir. The audience, please, participants, respond in the chat box if you can. Any guess can be taken.
Let me give 5 more seconds for this. We'll proceed.
So we have a response by Tarangini ma'am. She
Huh?
says 60%. Is it
81.
60%?
It is 81.4%, ma'am. You are quite close.
Okay.
Uh, the after I think 2014 there has been a lot of focus on household toilets and the fruits are visible. This is census 1881 sorry census of 2011. I'm sure the many of the states have become open defecation free now. So that means that we are reaching towards 100% of household toilets. Next question. What is the percentage of households in India which is connected to sewerage lines? If anybody can make a guess.
If participants, please respond in the chat box. You can take any guess that what is the percentage of households in India which is connected to sewerage lines. So we are waiting for the responses of the participants. I request you to please respond in the chat box. So we have a response by Tarangini ma'am again. She says maybe 70%.
No. The answer is 32.7%. Only 32.7% of the households in India are connected to sewerage lines, and most of them from the urban scenario, urban cities. Next
So
question. What is the
that's
percentage?
a pretty low, sir, percentage. Is it
It is
so
actually,
such
it is.
low?
Uh, the CPHWO manual, which is the manual for sewerage and sewerage treatment plants, it states that out of the all the households, 32.7% are connected to sewerage lines. This is quite evident that our villages do not have sewerage lines; they only have open drains, right? I'm sure everybody must have been to a lot of villages and cities where you see sewage being dumped into the open and into the open drains, nalas. So the cleanest city in India is Indore, right? So it is clean in terms of solid waste, but it is not so clean in terms of liquid waste. So cities, about 70 to 80% of city sewage is being treated in the centralized sewage treatment plant, but still you see that the drains which are flowing are still full of wastewater. So this is the scenario. So then comes the next question. What is the percentage of sewage generated in class 1 and 2 cities? Class 1 and 2 matlab tier 1, tier 2, tier 3 cities being treated in sewage treatment facilities. Does anybody know?
Yes, participants, please respond to the question that what is the percentage of sewage generated in class 1 and 2 cities? being treated in sewage treatment facilities. So I think around 80% of the water which we get, that gets 80 to 85%, that's completely getting converted into this sewage.
I'm sorry to bust your myth, madam. It is only 31%.
Oh God, that's too low, sir.
Yes. Then comes the final question. What is the percentage of all surface waters in India being contaminated by sewage? Can anybody imagine, or can anybody just give up a figure?
So I think 100% of surface water is being contaminated. Not even 100, maybe not 100, 98% is getting completely
Yes.
contaminated.
So actually it is more than 75%. I mean, close to the 75% figure. So imagine a country like India, which has lots of rivers, lots of lakes, and in the present scenario, after we have become open defecation free, we have shifted from open defecation to polluting our rivers and lakes. So this is quite unsettling for me at least, and for other nature lovers, that what is happening, what is really happening on ground. Let us explore all of this in this presentation. My aim for all these questions was to bring to the attention of the viewers that India is lagging behind in a lot of ways and polluting its rivers and lakes to such an extent that we cannot drink water from all of these areas. Even if you go to Haridwar, you can't drink water directly from Ganga. You have to filter it. In Haridwar, there is a big water treatment project which is taking water from the Ganga and filtering it and then giving it to the households. Why can't they just give it directly? Because it is coming directly from Himalayas. But the reality is, it is also taking all the pollutants, solid waste, liquid waste, from the upstream villages and cities. Let's start with the presentation, madam. Uh, I am a founding partner and I handle the research and development and execution in MLK Waste Management LLP. We founded this with I founded this with my childhood friend Dushyant Sachdeva. Uh, we were very passionate about nature. I mean, we have lived in industrial area in Bhopal with lots of trees surrounding us and lots of drains surrounding us. So we were always passionate about how do we clean this, how do we change this. So we started this in 2014, and it has been quite some journey for the last 7 years. We have built expertise in many fields. Major of them are natural treatment technologies for effluent sewage coming out of different industries like hotels, hospitals, um, industries, municipal sewage and all. Our major focus is on improving and innovating in decentralized wastewater treatment system space, which is DWATS, which we call DWATS. I'm sure many of the people might know about DWATS. We call it DWATS vortex based STPs. We also have natural treatment technique of fecal sludge treatment, which we have learned and are developing with one of our channel partners in CDD, CD Society Bangalore. We also have expertise in mechanized treatment technologies for STPs like SBR based STPs, MBBR based STPs, dissolved air flotation based ETPs. Some of the projects that we have done are 2.5 MLD project in Indore, a 1.2 MLD project in Amarkantak, which we are executing right now. Then we are also present in managing the waste of aquaculture. The system is called Recirculating Aquaculture Systems, where we can grow more fish in small land with the use of a filtration system that we have developed. Okay, so in these 7 years, we have built our presence in 6 states: Madhya Pradesh, Chhattisgarh, Maharashtra, Odisha, Assam, Delhi. In all of these states, there are about 30 cities where our treatment plants are present. And we have projects in pipeline in Kuwait, Maldives, and other regions of India. So, all in all, till now, we have made more than 250 sewage treatment plants and effluent treatment plants, and we are very proud to say that all of our treatment plants are in working condition because of our efforts and moreover because of our clients' efforts. We actually want our clients to be aware about what are STPs, how we can run them efficiently, so that they can reuse the water themselves, save a lot of costs, and help the environment in turn. Interestingly, I think cumulatively we are treating about 5 to 6 crore liters of water every day through our sewage treatment plants. So this was about our company. Let me dive more into the technology aspects behind our efforts, because we have a technical audience also. Uh, I'll start with decentralized wastewater treatment systems, DWATs. Traditionally, DWATs is a combination of different technologies which have been used in the past. Some of them being primary sedimentation tanks, anaerobic baffled reactors, anaerobic filters, horizontal planted gravel filters, and oxidation ponds. So this was a treatment system which has been used in India quite a lot by a lot of people. It takes up a lot of land, a huge amount of land. For example, one of the first DWATS plants which was built was near Pondicherry in Arvind Eye Hospital. It is still running very well. They are using the water from ponds in various activities like horticulture, flushing, etc. But it takes a lot of land area to build all these things. For example, just to give you the number behind it, for 1 kiloliters of water being treated every day, you need at least 3 meter squares of land. Or for 100 KLD, which is a medium sized STP of any colony, you would need at least 300 meter square of land by using traditional DWATS methods. What we did was we tried to reduce the size of decentralized wastewater treatment systems. Please mind that there is no mechanical treatment in this DWATS whatsoever. To reduce the sizes, we started practicing we started modifying the DWATS to fit the sizes in urban areas, in urban cities. You can see one of these schematic diagrams of DWATS that we practice. There is no horizontal planted gravel filter other than the main structure. You can see a horizontal planted gravel filter on top of the structure. You can see a vortex. What is a vortex? A vortex is nothing but a vessel where swirling action of water, जिसको भंवर कहते हैं हिंदी में, जिसको भंवर कहते हैं हम हिंदी में,
Hello.
वो एक yes, is there a
Participant, yes, if you have a question, please raise your hand. Maybe there was some disturbance.
Okay. So what this vortex does is it induces oxygen into the wastewater, which is already treated to great levels after the anaerobic filters, and it makes the wastewater rich with oxygen. Along with the horizontal planted gravel filter, what we try to do is achieve biological nitrogen removal, biological nutrients removal with the plants, with the biofilm generated in the cinder media or gravel media that we use in the horizontal planted gravel filters. We do not use any filters in this treatment, and the water is absolutely safe to use. There is no smell. The treated water conforms the PCB guidelines of 10 BOD, 50 COD, etc., etc. And most of our clients are using this water in flushing, in horticulture, etc. So this is our modification that we have done to fit this STP into the urban scenario, into places where they have less land and still want a working STP. Let me show you some figures behind the DWATS vortex treatment systems. So this is a comparison sheet of different technologies which exist in decentralized STPs in India. The most popular of them being Mdbr, FAB, SBR, phytoroid treatment technique, and Water treatment technique. Let me bring your attention to the last row. Please look at the lifetime cost of the STPs. Lifetime cost I am taking as 25 years. Generally, we take concrete structures ki life as 50 years, but let us limit ourselves at 25 years. You see there is a huge difference between, let me just make it clear that these numbers are not adjusted according to any inflation rates, etc., because we wanted to make it quite simple. You see the lifetime cost of an Mdbr unit is 1.59 crores, FAB unit is 1.62 crores, SBR unit is 1.41 crores, phytoroid is 94 lakhs, and Dewatts vortex is 65 lakhs. Phytoroid and Dewatts vortex being anaerobic treatment techniques, or you can call it a natural STP because we are using gravity based and anaerobic bacteria for treatment. You can see that there is 2.5 times difference between Mdbr and Dewatts vortex systems. So this is because we use only practically just one pump for the treatment of wastewater, and that too which drives the vortex tube. Other than that, we do not use any pumps. Yes, if there is a requirement of pumping sewage out of deep tanks, we have to use a pump there invariably. And you can see that the difference is due to the electricity costs. Electricity costs in last, I think, 6th or 7th row, 2.5 lakhs is the yearly electricity cost for a 100 KLD plant of Mdbr, and compared to Dewatts vortex, it is just 40,000 rupees in a year. So this is where decentralized wastewater treatment systems, Dewatts vortex, hold value, and we are trying to promote it on all the locations that we can, so that because there are less machines, because there are less operator involved, these technologies tend to perform their lifetime. There are no machines which need to be repaired. There is just nature and it plays its part. You just have to look for some inconsistencies happening in the STP. I mean, vigilance is still required, but very less when compared to mechanized treatment plants. Let's look at the numbers. Imagine what is the per liter cost of water recycled using the table in the before slide. Per liter cost of water treated of 100 KLD STP in Dewatts vortex STP in 25 years, normalized to 25 years, is 0.0071 rupees. When compared to per liter water cost of a tanker, it is 0.05 rupees. Narmada bill, I have taken assumptions of 1000 rupees bill for 1000 liters water supplied per day. The cost comes out to 0.033 rupees. Imagine what we can, what is the quantum of cost that we can save by recycling water. We can save about 1.18 crore rupees. I mean, a colony of 150 houses can save 1.18 crores of rupees in 25 years if it is shifting to a well-made STP and reusing its water wherever it can. So these numbers speak for themselves. Sewage treatment plants should be used. Sewage treatment plants are the need of the hour. Sewage treatment plants help you in managing your own financial resources, water resources, and obviously they have environmental benefits as well. This is my case. Does anybody have doubt in these numbers? If anybody does not have a doubt, let me proceed. Okay, let's proceed. Probably you can take the doubts later. So, ma'am, can you see the all the 4 photos of Dewatts vortex PGF
Yes,
based
sir.
STP?
Yes, sir.
Okay, so let me just, can you see my cursor as well?
Yes, sir.
Okay, so this is a 350 KLD a sewage treatment plant made in one of the colonies of Bhopal development authorities. And you can see the PGF being present in front of the operator room. This was the condition of plants after 1 month of commissioning. This was the condition of plants, the below photo, after just 3 months of commissioning. Lot of nutrient uptake is being taken by these canna plants. Acha, let me just introduce you to the wetland system. I'm sure most of you will know what are wetlands and what are wetland plants. These are phragmites which take up a lot of nutrients from water and grow. They can survive on water itself. Their roots go into the water, make bulbs, make a lot of housing for microbes, which in turn treats water. Attached growth process जिसको कहते हैं हमारे सीवेज ट्रीटमेंट की लैंग्वेज में अटैच ग्रोथ प्रोसेस बहुत अच्छे से होता है. प्लस the gravel which is present also gives a lot of area for microbes to grow, generally aerobic microbes, and on the deeper layers anaerobic microbes. So what we are trying to do in this sewage treatment plant is give the biological nutrient removal a chance in natural STP. आजकल MBBR based STPs में SBR based STPs में बहुत फोकस है गवर्नमेंट का to remove the nutrients before discarding the water. आप सभी ने देखा होगा कि आजकल जितने भी टेंडर्स निकलते हैं गवर्नमेंट के STP से रिलेटेड, सॉरी सब बायोलॉजिकल न्यूट्रिएंट रिमूवल पे फोकस करते हैं. On the left you can see two bottles from which we have taken the treated wastewater sample. I mean, can you make the difference if it is normal drinking water or treated sewage water? So
I find both the things are similar only. They look similar.
They look similar. They look like drinking waters, but they are in fact treated wastewaters from our different sites. You can see manholes behind. You can see manholes under this bottle. So this is actually my hand taking out the bottles from the treated water tanks. So this is the level into which we can treat water. There are many videos of treated waters of decentralized wastewater treatment systems on our YouTube channel as well, and different YouTube channels of different companies. Okay. There is a small video that I would like to show you of one of our treatment plants. You can see canna growing on the horizontal planted gravel filter. I'll start this video.
नमस्ते. ये हमारा MLK वेस्ट मैनेजमेंट की एक टेक्नोलॉजी है जो कि हमने हमारे मेंटर्स से सीखी है, और इसमें हमने खुद से कुछ एडिट्स किए हैं ताकि पानी और बेटर ट्रीटमेंट हो सके और कम से कम स्पेस में एक सीवेज ट्रीटमेंट प्लांट बन सके. ये हमारा ट्रीटमेंट प्लांट है जिसमें टॉयलेट्स का पानी, बाथरूम्स का पानी आके प्योरीफाई होता है. इस ट्रीटमेंट प्लांट की खासियत ये है कि ये सिर्फ एक पंप इस्तेमाल करता है अपने पूरे ट्रीटमेंट के लिए, जो कि ये वॉर्टेक्स ट्यूब जो हमने बनाया है, ये वॉर्टेक्स ट्यूब को फीड करता है एरेशन के लिए, और इस वॉर्टेक्स ट्यूब से पानी जाता है प्लांटेड ग्रेवल फिल्टर में, जहाँ पे हमारे कैना के पेड़ हैं और भी जो मार्शी प्लांट्स होते हैं वो पानी को एरेट करते हैं, इसमें से न्यूट्रिएंट्स निकालते हैं ताकि पानी हम यूज़ कर सकें. ये पानी अभी यूज़ होता है इस कॉलोनी के गार्डन्स में. ये कॉलोनी है भोपाल में जहाँ पे हमने ट्रीटमेंट प्लांट लगाया. आइए मैं आपको दिखाता हूँ इसका ट्रीटमेंट का कैसा पानी का लेवल है. ये हमारा पानी है जो ट्रीट होके आ रहा है. आप देख सकते हैं काफ़ी साफ है, और ये फ्लशिंग में इस्तेमाल हो सकता है और गार्डनिंग में इस्तेमाल हो सकता है, जिससे कि पूरी कॉलोनी का करीब 50% पानी हम बचा सकते हैं ये ट्रीटमेंट प्लांट से अगर पानी भी यूज़ करते हैं तो. थैंक यू.
So this was a small demonstration of one of our treatment plants in Bhopal. This is working pretty fine.
So we have a question by Dr. Ratnakumar sir. He says how DWAT's vortex is technology-wise different than phytorite bed technology.
Okay, so phytorite treatment system utilizes some of the same components, like the primary sedimentation chamber same hai. Anaerobic baffled reactors are a little different in terms of the assumptions that they do. Our ratios and the assumptions that we take in our empirical system of Dewars vortex and our calculation sheets are different from phytoroid treatment system. Phytoroid में ऐसा होता है कि आपके baffled reactors की length versus width ratio कुछ भी हो सकती है. हमारी length versus depth ratio is always same. So this is a small technical difference. आप हमेशा देखेंगे हमारे प्लांट्स में हम लोग का स्टैंडर्ड डेप्थ होती है 3 मीटर्स की and the length of maximum length of anaerobic baffled reactor unit is 1.1 meters or 1.2 meters. Then there is a difference in how anaerobic filter is taken. Anaerobic filter हम लोग की डिजाइन में is different. We put the anaerobic filter material, the gravel or cinder or media. I'll just go to the schematic diagram. You can see there are this green structure is a perforated slab in which डाउनफ्लो पाइप से सीवेज आके अपफ्लो करता है. दिस इज अ परफोरेटेड स्लैब जिसमें 2 इंच के होल्स होते हैं एंड दिस मीडिया बोल्डर मीडिया इज सिंडर मीडिया विच वी यूज इन फाइटरॉइड ट्रीटमेंट सिस्टम. ये इसको इसको कहते हैं अपफ्लो एनारोबिक फिल्टर. फाइटरॉइड ट्रीटमेंट सिस्टम में डाउनफ्लो एंड अपफ्लो दोनों चीजें यूज होती हैं. They make use and they plant the trees in the anaerobic filter itself. So they are trying to make anoxic conditions and anaerobic conditions and aerobic conditions in the same system. We are not trying to do that. We are only trying to make anaerobic systems because whenever the aerobic conditions are introduced in any attached growth process, the bacteria multiplies about 10 times faster. What this does is this creates a problem of choking in the filter media. So this we have ourselves implemented just one phytoroid treatment system where we faced a lot of difficulty. It got choked in about 8 months. It was a hotel site. There were many reasons behind it, but one of the reasons was aerobic and anoxic conditions in the gravel bed. So which is why we only use anaerobic filters. इसमें उसके बाद हम लोग एरेशन के लिए एक अलग वॉर्टेक्स सिस्टम और पीजीएफ सिस्टम यूज करते हैं जहां पे वी पुट बिग सिंडर मीडिया 3 इंच to 4 inches. Generally what I have seen in phytoroid treatment system is जो ग्रेवल का साइज होता है नॉर्मली 50 mm 20 mm वो ग्रेवल का साइज यूज करते हैं. इट हैज लेस void spaces जिसकी वजह से वो जल्दी चोक भी होता है. So this is my take on difference between phytoroid and Dewars system. I hope this answers your question, sir.
Sir, if you have any other query, please let us know. Sir, the gravel size which is used in this Dewars system is different as compared when we see the phytoroid technology. Said there's a larger gravel size that they use.
Yeah, so we use about 4 inches in nominal diameter of cinder media. Cinder is a different media. I'll take out some photos and show you at the end of the presentation. Cinder is a porous media. It comes out of the blast furnaces of steel mills. Blast furnace से जो आयरन निकल जाता है और उसका जो सिलिका रह जाता है वो that is very porous. It is lighter in comparison to normal गिट्टी जो जिसको अपन बोलते हैं crushed stone, and it provides a lot of surface area. I think 5 times more surface area than any gravel media. So the bacteria colonies are very much thrive in this environment. I hope this answers the question, madam.
Yes, sir. Thank you, sir.
Okay. Shall I proceed?
Yes, sir.
Okay, so we have seen this video. Other sewage treatment technologies are quite popular. Sequential batch reactor. I have copied one of our process and instrumentation diagrams here. It is a standard mechanized treatment process. Sequential batch reactor, sequencing batch reactor is a activated sludge process where we treat sewage in batches. So normally there are minimum 2 SBR basins. You can see here there are 2 SBR basins in this process and instrumentation diagram. There is a decanter basically the process is divided into 4 parts. One is the fill process. The other is aeration phase. Then the process, third process is settling phase, and the fourth process is decantation phase. So when the flocks are formed after aeration and we let them settle for about half an hour, 50% of the water can be decanted. So with a decanter, we use it and then we let it flow into chlorine contact tanks or filter feed tanks, and after that filtration can be done. This is a standard sequencing batch reactor process and instrumentation diagram. I will not delve into it much because this is practically available in all of the literature that we read in our MTech or BTech courses. This is a moving bed bioreactor system. Again, this is an attached growth process. It takes lesser amount of area than SBR treatment systems. It is very ideal for places which do not have too much land to offer for sewage treatment plants, small sewage treatment plants. General process is to primary clarify the water, pump the water into anoxic tanks. Anoxic tank is a place where anoxic reactions take place, reduction reactions of ammonia and nitrates take place to remove the nitrates in the system. Then there are Mdbr tanks. Generally, two tanks are present, and this is an example of extended aeration system where nitrification is achieved, the overflow of which enters into tube settler tanks. Tube settler tanks help in settling all the flocks that are made in the aeration basins, overflow of which can be taken into filters and then discarded into treated water sump or anywhere which we can use. Filter press assembly can be used to remove, to solidify the sludge, to remove the water from the sludge which is discarded every day. Filter press, sludge centrifuges, etc., etc. So this is just an introduction into the MBBR based STP. These are the treated water test reports from some of our STPs. The first one is from Macar Regalia in Bagli, Bhopal. You can see that this was working around at 50% of load, incoming load. I mean, it was not 100% load. It was performing very well. You can see the BOD as 4 mg per liter out of a Diverts vortex treatment plant. COD was 20, total suspended solids were 11, oil and grease was less than 2, etc., etc. The second is from an MBBR treatment system installed in Raipur. You can see that the BOD is 7.2, COD is 27.2, TSS is 2.14. TSS was the result of the installation of tube settler tanks. Tube settler is a very highly efficient settling places where flocks can settle quite well. The third is again, I think, yeah, this is also a Diverts vortex treatment plant. Geet Sky Villas. The plant which I showed in the video, this is the same plant, and you can see that the BOD and all, BOD is 11.2, dissolved oxygen was 4.2, suspended solids were 186, it was quite a lot, COD was 58. So this was taken by Madhya Pradesh Pollution Control Board. They came to review our site and they gave this test reports to us. So these are some of the test reports which validate our treatment processes and obviously Diverts vortex as a good technology for decentralized wastewater treatment. Okay. Let us get to a case study. So this is a Maharajband Talab, where we as consultants are consulting Raipur Smart City Department Raipur in treatment of this lake. Because the series series mentions restoration of water body, restoration and conservation. I would like to give the example of this case study. So this is a very big lake. I think the area was 7 point something acres, and there were about 11 inlets of different drains which were coming in. A normal problem. Ma'am, let us keep this a very interactive session because this is the case study probably where we can connect in terms of water body restoration and our core topic of sewage treatment plants. So there were 11 inlets which were coming in, and there were two outlets of the Maharajban Talab. You can see this is a photo from Google Earth that lots of algae and etc. have developed on the north side of the lake. And on the right side of the lake, you can see a road. On left side of the road has been encroached with solid waste debris and all, construction debris. Uh, you can see on top there are inlet 1 and 2, inlet 3, inlet 4, inlet 5, inlet 6, 7, up to 11. So this lake is a heavily eutrophied lake. I'll come to the case study first. Problems that we identified were heavy eutrophication of lake waters, which generally happens in lakes which are receiving sewage from drains of the nearby communities. Dissolved oxygen was completely depleted into the deeper layers of lake, which makes the lake practically dead. There are no aerobic bacteria present in the lake, which are generally beneficial for water bodies. There are no fisheries present in the lake, which show that there is an ecological balance in the lake. So as you can see, the different inlets bring in about 3 mld of wastewater, which was the data given to us by the Smart City department. So our proposal was very simple. I think this is being practiced as a standard practice in rejuvenation of all water bodies. We have to close down the incoming drains and take their water to sewage treatment plants so that a treated water can be brought into the lakes. So what we proposed was two diverts units at different points with a cumulative capacity of 1 mld. We made 3 anaerobic baffled reactors and 1 anaerobic filter in these diverts units, and the cumulative treatment capacity will be somewhere between 75 to 80%. 75 to 80% of removal of TSS, BOD, COD, not nutrients, because anaerobic treatment systems are not that efficient in removing nutrients specifically phosphorus and nitrogen. Then there was one big drain which was coming in. It was, I think, 2 mld of water was coming from that big drain itself. So we proposed a Mdbr STP, extended aeration system, which will remove the BOD COD by up to 80%, more than 80% in fact. And this will not remove the nutrients, because ammonia will be nitrified into nitrates, and phosphorus removal won't happen. Very less phosphorus removal will happen when we remove the excess sludge which is generated during treatment. Then a good proposal is, an apt proposal is to remove the nutrients of the lake with the help of floating wetlands. Wetlands are natural nutrient takers from anywhere. You can see wetlands present in many seashores, many banks of rivers and lakes and all. Already they are present. So what we proposed was 3,000 square meters of floating wetlands with submerged aerators to improve the dissolved oxygen in the deeper layers of the lake. We hope this project is under evaluation by the government, and we hope that this gets implemented so that there is a good example of lake rejuvenation. Approximate project cost was about 5 crores of treating 3 mld and treating the lake wastewater. I'll show you where you can see that a wetland area of lake of inlet 11 was 100 meters square, which we have proposed at the inlet point of drain 11. Similarly, wetland area in the center of the talab is 200 meters square. On every inlet we have proposed wetland area so that the nutrients can be taken out of the inlet, and the lake water will be significantly less eutrophied. It will have improved ecological balances. We hope that a lot of fishes will return to this lake and make the ecology balanced again. This is a small case study. I am open for questions. I also have one more case study of published by CDD because it is very relevant to the topic that we are discussing. I'll show that to you as well. Or let me show that first, and then we can take up questions on this. One second. I think I think this is the fact sheet. Okay, so this is a case study made by CDD Society on water body rejuvenation and cases that are happening in India. A very interesting one that everybody might know is the Rajogri Lake, which was done by Delhi Development Board. Good results were obtained from it. A waste area was rejuvenated into a lake with the help of floating wetlands and divert systems. I'll just come to that. This is a very interesting case study. You can see the interventions that have been done. Diversion arrangement was done for incoming drains. Primary settling tank was introduced. Anaerobic reactor was introduced. Pumping tank, swab, lake with floating islands. So this is you can see different horizontal planted gravel filters are used here. Settling tanks are used here, and then the water is going into the central lake. You can see the floating wetlands on the lake, some thriving ones and some new ones. The results are as follows. So you can see that at point P1 inlet, the BOD was 190 of the drain, COD was 410, total phosphate was 5.6, ammoniacal nitrogen was 20, and TSS was 190. These are the major parameters which we look at. Then at P5, 0.5 at the center of the lake, it is heavily reduced. TSS is reduced by about 50%. BOD is reduced by about 90%. 16 BOD is evident. COD also has been reduced by 90%. Phosphates have been reduced by practically 80%. Ammoniacal nitrogen has been reduced by 80%. So this is a very normal case study where we can trap the incoming wastewaters coming into the lakes and use some kind of ecological techniques, natural techniques like floating wetlands or floating islands to remove the pollutants which are existing in the lake and improve the biological characteristics of the water as well. This will help in cleaning the lake. This will help in different fishes being reintroduced into the lake so that they can balance the ecosystem in the future. We won't have to interfere in it again. This is a case study which already has happened. There are more case studies. I'll share it in the chat. This is a very interesting read that everyone should go through. I'm happy to take any questions on this, on use of sewage treatment plants and attached growth floating wetlands to purify lakes.
The participants are welcome to ask any questions if they have. Sir, I have a question.
Yes, ma'am.
So, like in the real case studies, for example, which you discussed right now, in which we have certain inlets where water is coming.
Yeah.
At that inlet, sir, if we plant that wetland or the floating island sort of thing, how will it treat the flowing water when it's having a lot of flowing water into it?
Ma'am, flowing water as in from streams into the streams? Okay, so the simple calculation goes like आप BOD estimate कर लेंगे आप BOD removal estimate कर लेंगे एक 1 meter square of floating island का approximately. Let's say the flow is 100 KLD, 100 meter cube per hour, and you want to treat it with, let's say 1 meter cube per hour treat कर सकता है आपका 1 meter square of floating wetland. So that makes 100 meter square of floating wetland for a stream of 100 meter cube per hour. ये simple सा calculation होता है. जनरली फ्लोइंग सिस्टम्स को एंकर करना पड़ता है फ्लोटिंग वेटलैंड से. We anchor it with weights on the into the lakes or into the streams, or we tie them off on nearby walls. So as water goes, the plants take up plants, and basically the essence of treatment in floating wetlands are the roots, which are roots are enormous. I mean, all the phragmites have small fibrous roots which are coming into the water, and the bacteria, they offer bacteria a very good attached growth medium to feed on the nutrients of wastewater that are coming in. So more than 95% of the treatment takes place due to the bacteria. Only 5% treatment takes place due to uptake of nutrients by the plants. So what we have to do is we have to keep harvesting those floating wetlands के जो plants उग चुके हैं उनको harvest करते रहना पड़ता है time to time, उनकी roots को harvest करते रहना पड़ता है time to time, so that the floating island is in a perfect state of treatment. I hope this answers your question, madam.
Yes, sir. Sir, one more thing, that the plants which are to be used in this type of technologies, can they be flowering plants as well?
Yes, ma'am. So, कैना जो मैंने आपको दिखाया था वीडियो में, that is a very good plant which takes up lot of nutrients, और उसमें बहुत सारे yellow, orange and red color flowers आते ही आते हैं. Other than that are phragmite grasses, vetiver grass, bulrush, cattail, ये सब grasses होते हैं जो कि flowering नहीं होते हैं. But yes, we can use any type of flowering plants which take up nutrients directly from water. It is not necessary that they have to be phragmites only.
So one more opinion I would like to have regarding canals, that how can we treat the water which is coming into canals?
Canals?
Or drains sort of things.
Drains and canals directly?
Yes.
So I remember there was a very good case study from one of the African countries where they had made a big drain as a place for floating wetlands. There is a simple process in which we can do it. Delhi is already doing that to its drains. It is creating barriers on the surface of wastewater to remove the plastic waste. Then what it is doing, it is increasing the flow time of water and putting bunds on different parts. मतलब जैसे आप मान के चलिए एक ऐसा बंड बना दिया है एक चैनल में, एक हाफ बंड ऐसा बनाया, हाफ बंड ऐसा बनाया, जिससे कि एक zigzag फ्लो बन जाता है, and putting different floating islands or attached growth treatment media in between of them so that water flows through them. So this is in which way efforts are being made to do this. There have been a lot of success stories as well. I do not have them documented right now, but I'll be happy to share it with you after this presentation.
Yes, so we would like that information to be shared with us and all the participants regarding the case study which we have been pointed out by CTD, and as well as the one which we are telling about the in Delhi, which is being practiced in Delhi.
Okay. I'll share all the documents at the end of the presentation. How do I share? Okay, how do I write something? So I'll do that afterwards.
So you can type in the chat box, but I don't think there is a document sharing option in the chat box. So probably it will be nice if you can mail it to me. I will be sharing it with the participants.
Yes. I'll email it to you, and probably you can share it with the participants. Okay.
So any more questions from the participants, please come forth. We can have a good discussion about this thing, because whatever Harshit sir has told, we can bring it into a lot of practice. A lot of area needs to be thought about regarding the rejuvenation of water bodies. That's the need of the hour. And as rightly mentioned by him, the scenario of the water treatment, which we think is very different as compared to the real situation which exists. So a lot of work is supposed to be done in this regards, because if we do not have water, we don't have life survival. So please come forward, participants. You are encouraged to interact with Harshit, so you can ask any question which you feel like.
Yes. Even if I can't answer, you can ask me anything.
He will definitely get back to you.
Yes. So this is one of the examples of Putenahalli Lake over the years. You can see 2008 दिसंबर में बिल्कुल पानी नहीं दिख रहा था and 2017 मई में कैसा चेंज हुआ है. So what they have done is they have created a small sedimentation basin and treatment basin at the inlet points और उसका overflow बस lake में जाने दिया. तो you see as less and less total suspended solids get into the lake is a biological entity. It will try to rejuvenate itself also. There are only some interventions that we have to make to facilitate that. This is what I feel. Meanwhile, whenever जब लोग जो क्वेश्चंस पूछने के लिए सोच रहे हैं तब तक मैं और कुछ ढूंढ लेता हूँ इसमें से.
So we have a question by Vijayant Pandey. Please, you can unmute yourself or even you can type in the chat box.
Yes.
He raised his hand. He or she, I don't understand. Is it Vijayant ma'am or is it Vijayant sir? Probably he lost the connection, sir. He will be getting back.
Okay. So you can see this Hembagodi Lake. This is where.
Hello, sir.
Yes,
Yes, sir,
please.
we got it.
Yeah, good afternoon, sir. First of all, very nice presentation given by you. I have a query about the harvesting period of this plant. Is there any harvesting period of the plant? Like the plant itself have a certain limit to uptake the pollutants from the water. So there is a need to harvest it for after the particular period of time or something.
Yes. So there is a definite rate of uptake of every fragment based fragment plant. Like for example, canna. इसका एक स्पेसिफिक रेट ऑफ अपटेक होता है. आपको ये विजुअली ही देखना पड़ेगा. जब स्ट्रॉन्गर वेस्ट वाटर्स होंगे तब ये जल्दी बढ़ेगा. जब इतने वेस्ट वाटर मतलब जब वीकर वेस्ट वाटर होगा तब ये धीरे बढ़ेगा. लीनियर रिलेशनशिप. आप मानेंगे नहीं, कुछ साइट्स पे हमारे ये 10-10 फीट तक के बड़े हो जाते हैं कैना प्लांट्स. एंड व्हेन दे जब 10 फीट तक के बड़े हो गए उसके बाद में इनके रूट्स भी काफी सारे हो जाते हैं. इनको काट के डिस्पोज करना बहुत जरूरी है बिकॉज दीज आर फुल ऑफ हेवी मेटल्स जो ये टेकअप करते हैं, पोल्यूशन जो न्यूट्रिएंट्स हैं. अब इनका फिक्सेशन भी करना होता है. एक सर्कुलर इकोनॉमी कंसीडर करिए सर इसको. जब तक कि आप वेस्ट वाटर में जो न्यूट्रिएंट्स हैं उनको कहीं फिक्स नहीं करोगे, लेट्स से इन डंपिंग यार्ड्स और समथिंग, तब तक कि वो उसमें से जाएगा कहाँ, उसी में रहेगा. मान के चलिए हार्वेस्ट अगर नहीं किया और ये प्लांट्स वहीं टूटने लगे तो दे विल रिटर्न दोज न्यूट्रिएंट्स इनटू द लेक वाटर इटसेल्फ. तो इनका एक स्पेसिफिक टाइम होता है. इट इज गवर्न्ड बाय कि वो आप कितना उसको रखना चाहते हैं. जैसे आप अपने घर पे गार्डन को ट्रिम करते हैं उसी तरीके से इनको भी ट्रिम करना है. इसका कोई सेट टाइम नहीं है. आपको बस देखना पड़ेगा कि अगर ज्यादा घने हो रहे हैं, ज्यादा बड़े हो रहे हैं तो इनको ट्रिम कर देना है बस. सो व्हाट दे विल डू इज दे विल यूज न्यू शूट्स to make new branches and new plants.
So one month query is there. Is there any document for the safe disposal of this harvested plant?
There might be, yes. I have lots of documents on my computer. I'll definitely share it with you. I'll take your contact details from madam.
Okay, so thank you, sir.
Yeah. जनरली सेफ डिस्पोजल क्या होता है सर? आई मीन बहुत नॉर्मली अगर अपन बात करें,
No, actually, sir.
व्हाट इज द सेफ डिस्पोजल फॉर प्लास्टिक? लेट्स से क्या है आपके अकॉर्डिंग प्लास्टिक डिस्पोजल का सेफ ऑप्शन?
प्लास्टिक डिस्पोजल में आई थिंक सर अगर 3R थ्योरी की बात करें, सो फर्स्ट ऑफ ऑल अगर डिस्पोजल की बात कर रहे हैं सो इट मींस रिसाइकल इज द बेस्ट ऑप्शन फॉर द रिड्यूस द प्लास्टिक.
चलिए रिसाइकल कर दिया, कभी ना कभी तो प्लास्टिक की लाइफ एंड होगी और तब उसको कैसे रिसाइकल, तब उसको कैसे डिस्पोज करेंगे?
सर एक्चुअली द फर्स्ट ऑप्शन इज वी शुड रिड्यूस द यूज ऑफ प्लास्टिक टू.
एग्जैक्टली.
या
ठीक है.
Actually, sir, my concern is like if
so when they are used into some much more fruitful way, Like if the end of this product goes into something which is made useful, then I think probably that is not going into the environment. So that
Exactly.
might be the way out of this.
Exactly. Plastics are made out of petroleum-based carbon chains. कार्बन चेन्स को तोड़ने के लिए आजकल पायरोलिसिस प्रोसेसेस हो गए हैं, पायरोलिसिस प्रोसेसेस जहां पे प्लास्टिक को कन्वर्ट किया जा सकता है पेट्रोलियम में वापस. तो इफ यू कन्वर्ट प्लास्टिक इनटू पेट्रोलियम and whenever we burn petroleum, that compounds in the plastic will be reduced to its basic levels. I'm giving you a practical example. Carbon dioxide and water. इस तरीके से प्लास्टिक का डिस्पोजल सेफ डिस्पोजल माना जा सकता है. Dumping is not a safe disposal for plastic because it will take about 500 to 1000 years to disintegrate. और वो ground को contaminate करेगा ही करेगा. Another safe disposal, I'll tell you of these canna plants. Let's say, for example, canna. भाई canna is क्या बोलते हैं, एक organic plant है. This will disintegrate in the nature if we bury it in the ground. So there are disposal sites where, like in fecal sludge treatment plants, जहाँ पे because these plants take up a lot of heavy metals as well, heavy metals, the compounds present in our antibiotics and all, वो सब भी आजकल waste waters में जा रहे हैं. There are many studies which are being done to identify compounds in the waste waters due to the use of medicines or chemicals. So these have to be disposed of by either pyrolysis, turning them into ash and then disposing it in the ground, or into plants where these can be made into methane and all. There are covered solid waste disposal sites which can convert these into useful gases. So this is one option. I'll also share a document with you which might give more options.
So can these plants be converted into biofuel, or some biofuel based plants can be grown into these sort of islands? Is it possible?
Very interesting question, madam. Do you know about seaweeds? Seaweed?
Yes,
So
sir.
there is a startup of IIT Madras which has successfully converted seaweed into biofuel, which is being used in as additives to petrol and diesel and all. So if they are converting those plants, I mean, I'm sure those plants must have the required minerals and required structures to be converted into biofuels. These also can be converted. I believe these can be converted. I do not have any data for it. But yes, I mean, one of the fuel which they can be converted into is methane. आप इसको उसमें डालिए, क्या बोलते हैं उसको, बायोरिएक्टर, बायोगैस प्लांट में डालिए, ये कन्वर्ट हो जाएगा. दिस इज अ रिच सोर्स ऑफ कार्बन एंड मीथेन इज व्हाट, मीथेन इज कार्बन एंड हाइड्रोजन. तो डिकम्पोज होते होते वो मीथेन बन ही जाएगा.
So there is an option that we can instead of replace these plants with some biofuel based plants also. Probably we can do that.
Definitely.
So thank you so much, Vijayan sir, for igniting our thoughts regarding
Yes.
how
Thank you so
we
much.
can properly dispose.
Yes.
That was a lovely question, sir. In fact,
Thank
that created a lot of series of thoughts into our minds that how can we also think
Yes.
about the proper disposal.
In fact, there is a professor in Vishakhapatnam, I guess. His story came up in the Better India. I think everybody should follow the Better India. It is a startup which brings out positive news from all over India and publishes it. वो professor is converting plastic into biofuels again by using different pyrolysis methods on a smaller scale. So this is a good read for everyone.
Any of the
Any more?
participants, please come forward and ask any question, because the whatever simplest question you ask, it definitely leads to a lot of new things which we can even think about. So the participants are really encouraged to come forward and ask. The forum is open to you all. You can unmute yourself or you can even type in the chat box.
I'll share this, ma'am. I'll share this document. Everybody should read this. These are quite some things which have been done in India itself. All of these are Indian examples. You can see there are different bunds being made, a DWATS plant being 8 MLD plant being installed, and then it is getting into the lake. There is
So I
clear
think
removal of
these days a lot of awareness is being created regarding rejuvenation of water bodies, and
Yes.
significant work is being done by entrepreneurs like you, and it's really inspirational. And I hope that sometime in future we might see all the water bodies get rejuvenated, probably in the decade's time.
Hopefully in our lifetime.
Definitely, sir. We hope so because every day when new people join this particular effort and the journey becomes more interesting as well as a lot of things can be done in a shorter duration of time.
Yes.
So we
So,
all
Sharma,
are here together, all the participants are here together just for this one effort that we get how to rejuvenate our contaminated water bodies and how we can in some small way contribute to the revival of nature. That was the main effort for this particular training program, and we are very thankful for contributors like Harshit sir who agreed and accepted our request, shared the experience with us. Yes sir, you may proceed with this recirculating aquaculture system, sir.
yes. So the first part of the presentation was about human interventions for contributing into pollution to our water bodies and solutions for it. This is an example. Aquaculture is an example of human practices in agriculture which might pollute our water bodies. A very simple thing which I would like to share is ओवरफिशिंग ने वैसे भी हमारे नेचुरल रिसोर्सेज को नेचुरल फिशेस को कम कर दिया है नेचुरली नाउ व्हाट वी हैव टू डू इज वी हैव टू गेट इनटू फार्म फिश आजकल फार्म फिश आई थिंक इट टेक्स अप मोर देन 50% ऑफ द वर्ल्ड्स कंजम्पशन फार्म फिश जो कि पॉन्ड्स में और केजेस में ये सब में बनाई जाती है नाउ एज फार्म फिश becomes more and more accepted in the Indian markets, and there are more people coming into farmed fish. What happens is आप एक तालाब में अगर खूब सारी मछलियां डाल देंगे तो मछलियां तो गंदगी तो करेंगी ही करेंगी आप खाना खिलाएंगे उनको and that is creating problems in areas like Hoshangabad. I'm sure everyone might be aware of Hoshangabad. It is a city near river Narmada. Uh, there is a very peculiar problem in Hoshangabad. होशंगाबाद में जो ग्राउंड वाटर है that is probably at a level of 20, 30, 40 feet. And that groundwater is being polluted by intensive fisheries happening in ponds. Lot of nutrients like nitrogen and all, and lot of metals which are there in fish feed are getting into the bore wells of people. So this is a practical problem which is arising in all of the areas where pond fishes are reared. So this is a technological innovation that we have, not innovation, I mean obviously this is present all across the world. It is called Recirculating Aquaculture System. What is a Recirculating Aquaculture System? It is basically rearing more fishes in smaller amount of land with the help of a filtration system. हम क्या करते हैं एक टैंक में खूब सारी फिशेस को डालते हैं और उनका जो गंदगी रहता है उसको पानी के द्वारा निकाल के एक ट्रीटमेंट सिस्टम में उसको प्यूरिफाई करके वापस से उस पानी को फिश टैंक में डालते हैं व्हाट दिस डज इज इट uses 95% less water for per unit fish produced than traditional aquaculture. So this is a very upcoming field which is already being accepted in a lot of Asian countries, European countries, and what it has minimal environmental impact. Minimal environmental impact. आप देखेंगे आप सभी को aquaponics के बारे में पता होगा. Aquaponics का एक पार्ट है RAS. RAS में से जो न्यूट्रिएंट्स निकलते हैं दैट इज यूज्ड फॉर ग्रोइंग डिफरेंट वेजिटेबल्स. सो एक तरीके से सर्कुलर इकोनॉमी वहीं बन गई, सर्कुलर डिस्पोजल ऑफ और सर्कुलर यूटिलाइजेशन ऑफ न्यूट्रिएंट्स वहीं पे बन गया. सो दिस इज हाउ fisheries is evolving, and we have created this product. It is a very interesting product. I would just tell you why RAS is important. In India, fisheries is increasing at a rate of 10.88%, which is whopping. I mean, no other sector is growing at this rate. And as and जैसे जैसे ये बढ़ता जाएगा वैसे वैसे ही स्ट्रेस्ड वाटर एरियाज में और प्रॉब्लम आती जाएगी, लाइक इन होशंगाबाद, जैसे मैंने आपको प्रॉब्लम बताया. अब टू tackle these problems which will be there in the future, you have to have good solutions like biofloc, like RAS, like aquaponics, which replace the traditional methods with environmental friendly methods. So it is very important. This is a simple diagram of this is a simple diagram of RAS setup. In fish tanks, we remove the solid waste, solid filtration. It is very similar to sewage treatment plant. If you see, what we are doing essentially is removing the solids, converting ammonia into nitrates in the biofilter, disinfecting the water with the use of ozone, and making the water oxygen rich with the help of oxygen generators, and giving it back to the fish tanks. So you see, only 5% of the fish tank volume is required as fresh water every day. 95% is recycled on a daily basis. So this is the beauty of this technology. You can traditionally, मैं इसका economic impact बताऊं आपको, तो traditional aquaculture में per square meter area में you can grow 2 to 5 fishes per square meter of pond area. In RAS, per square meter of this fish tanks, you can grow 50 to 100 fishes. 50 to 100 fishes is 50 times more than traditional aquaculture. So what this will do is this will free up a lot of space which ponds and all are taking, and probably use it for better purposes. This is a video of a recirculating aquaculture system that we have installed in Indore. Again, this is in Indore. We have installed about 6 RAS plants across India. 2 in Bhopal, 1 in Indore, 1 in Bhubaneswar, Puri, and 1 in Assam. I'll play this video. Oh sorry, वीडियो बंद हो गया, सॉरी. मैम, दिस इज द राला मंडल एरिया.
नमस्कार, हम हैं इंदौर में शशांक चौरे जी के फ़िश फार्म पे, जहाँ पे 60 टन्स का एक प्लांट लगाया गया है हमारी कंपनी द्वारा, MLK वेस्ट मैनेजमेंट भोपाल. और आइए मैं आपको इस फार्म में ले चलता हूँ और आपको दिखाता हूँ कैसे इंस्टॉलेशन हुआ है. प्लांट के राइट साइड में हमारे सारे फिश टैंक्स हैं. यहाँ 8 टैंक्स लगाए गए हैं, हर एक की कैपेसिटी 1 लाख लीटर है. और लेफ़्ट साइड में RAS सिस्टम है जहाँ पे टैंक्स और मशीनरी प्लेस्ड है. एक टैंक के पास ले चलते हैं आपको. इस टैंक में पंगेशियस अभी डाली गई है मछली, और इसका जो ओवरफ्लो है वो इस ज़रिए एक वर्टिकल पाइप के थ्रू निकाला जा रहा है. बॉटम से पानी निकल के आता है और इस पाइप के थ्रू निकल के बाहर निकलता है। इससे लेवल भी मेंटेन्ड रहता है। पाइप की हाइट डिटरमाइन करती है कि लेवल क्या मेंटेन करना है। इन पाइप्स के थ्रू पानी निकल के कॉमन ड्रेन जो बीच में चल रहा है सभी टैंक्स के, इसके सहारे हमारे आरएस टैंक्स में पहुंच जाता है। किसी एक ओवरफ्लो सिस्टम को करीबी से देखते हैं थोड़ा।
You can see the water being recycled with
इसमें
help
दो
of pipes.
चैनल्स हैं पानी के निकलने के लिए। एक तो नेचुरल ओवरफ्लो जो इस पाइप के थ्रू मेंटेन हो रहा है, और बॉटम पे जो आपने येलो वॉल से देखा वो है इमरजेंसी वॉल्व, अगर टैंक पूरा खाली करना हो। ये आप देखेंगे कॉमन चेंबर है। इसमें लेफ्ट और राइट दोनों जगह से इनलेट आ रहा है साइड के टैंक्स में से, और सेंट्रल पाइप है जो कि 1 फीट का डाला गया है, जिसके सहारे पानी ट्रीटमेंट टैंक्स तक पहुंच रहा है। ये हमारा ड्रम फिल्टर है। ड्रम फिल्टर 70 माइक्रोन मेम्ब्रेन का डाला गया है, और 2 डाले गए हैं, पैरेलली हैं एक दूसरे के। और ये दोनों या तो टाइमर बेस्ड या लेवल बेस्ड दोनों तरीके से चलाए जा सकते हैं। डिपेंडिंग करता है कि फिश की लाइफ किस फेज़ पर है, क्या ज़रूरी है, कितना चलाना ज़रूरी है, ऑपरेटर को कैसा कन्वीनियंट है। ये देखिए अभी ये चल पड़ा ऑटोमेटिकली, टाइमर बेस्ड है। अभी ऊपर से जेट स्प्रे डाले जा रहे हैं स्क्रीन पे, और जितना भी स्लज होता है, जो सस्पेंडेड आइटम्स हैं, वो इस ट्रे में गिर जाते हैं, और ट्रे में एक पाइप लगी है। ये पाइप अब ग्रेविटी के थ्रू जितना भी स्लज इन दोनों ड्रम फिल्टर से निकलेगा, उसको ग्रेविटी के थ्रू एक एक्सटीरियर चेम्बर में डाल दिया जाता है। ड्रम फिल्टर के बाद हम बायो फिल्टर टैंक पे आ गए, विच इज़ द मेन कंपोनेंट ऑफ द एंटायर आरएस सिस्टम। इसमें बायो मीडिया है। ये आप देखेंगे इसमें बायो फिल्म भी बन चुकी है, वाइट कलर से ऊपर आप एक फिल्म देखेंगे। ट्रीटमेंट प्रोग्रेस में है। पानी जो बायो फिल्टर टैंक है ये 2 फेजेस में स्प्लिट है, और जो तीसरा चेम्बर है वो हमारा ट्यूब सेटलर टैंक है, वहाँ पे भी डीगैसिंग का काम हो रहा है। ये चौथा चेम्बर है, जहाँ जो आखिरी चेम्बर है रीसर्कुलेशन टैंक। इसमें सबमर्सिबल पंप्स हैं, और इन ओवर हैंगिंग पाइप्स के थ्रू पानी जो है ट्रीटेड वाटर वापस टैंक्स में डाला जा रहा है। ये नेटवर्क इस तरीके से बनाया गया है ताकि टेंजेंशियली इसकी पोजीशन हर टैंक पे जाके गिरे, और पानी को गोल घुमा सके हर टैंक के अंदर। ये आप देखेंगे अभी पानी चल रहा है इस टैंक में। पानी का रोटेशन बहुत ज़रूरी है ताकि फिश को ग्रोथ अच्छी मिलती है, उसको एहसास होता है कि वो एक बड़े तालाब में है या किसी जगह पे। इससे पहले कि पानी टैंक में गिरे, इसमें हाई प्रेशर से ऑक्सीजन डाली जाती है थ्रू कोन्स। कोन और वेंचुरी का ऐसा सिस्टम रहता है जिससे हवा जो है इसके अंदर डाली जा सके। आप ये देखेंगे, ये ऑक्सीजन जनरेटर आ गया आपका, जो कंप्रेसर के थ्रू, जो आप उसके लेफ्ट में देखेंगे, ये वाइट कलर की बॉडी का कंप्रेसर है। कंप्रेसर हवा डालता है इस सिलेंडर्स में। सिलेंडर्स उस हवा में से ऑक्सीजन बनाते हैं, और ऑक्सीजन डाल देते हैं ऑक्सीजन कोन्स के थ्रू लाइन में। और डिजॉल्व ऑक्सीजन पैरामीटर 7 से 8 से 10 मेंटेन हो सके, इसलिए ये सिस्टम ऐड किया जाता है। ये कॉमन पीएलसी बेस्ड और एचएमआई आप देखेंगे सामने, ह्यूमन मशीन इंटरफेस है सामने। इसके ज़रिए पैनल बनाया गया जिसमें सारे कंपोनेंट, जितने भी कंपोनेंट्स आरएस में लगे हैं, सबका इंडिविजुअल फंक्शनिंग हम चेंज या कभी भी मेंटेन कर सकते हैं, ऑटोमेटिकली या मैनुअल, जो भी चाहे। ये जो मैंने आपको ड्रम फिल्टर दिखाया था, ड्रम फिल्टर का अलग पैनल है। ये देखेंगे अभी टाइम इसमें घट रहा है, एकदम से जैसे 0 हुआ चल पड़ा, और 30 सेकेंड्स का इसमें अभी टाइम सेट किया गया है कि 30 सेकेंड्स ये चले। ड्रम फिल्टर अपने आप पानी, वो मोटर उसमें लगी और खींच लेती है, और जेट स्प्रे चालू हो जाते हैं। अभी आप देखेंगे 15 सेकेंड, 14 सेकेंड, इसके बाद ये अपने आप बंद हो जाएगा। और ये रुक गया है। अभी ये इस हिसाब से सेट किया गया क्योंकि मछलियों का साइज़ कम है, जो कि हम यहाँ के ऑपरेटर जो हैं इनके थ्रू भी हम देखेंगे। इनसे हमने कहा है थोड़ा सा फीड डालें आप, ताकि हम मछलियों का साइज़ कुछ देख सकें, देख सकें। आमतौर पे ये सजेस्ट करते हैं कि अभी मछलियाँ नहीं निकाली जाएं उनको छेड़ा ना जाए। फिर भी हम थोड़ा सा फीड डालने के बाद आप देखेंगे मछलियाँ कैसे ऊपर आके उस फीड को ले रही हैं। ये देखिए आप, पंगेशियस अभी मछली डाली गई है, 80 ग्राम के आसपास की बताई जा रही है, अभी हो गई होगी। और हर टैंक में लगभग 90,000 मछलियाँ डाली गई हैं, यानी कि 6-7 महीने बाद ये 9 टन के आसपास, 8 से 9 टन थोड़ी बहुत ही मोर्टालिटी होती ही है, 5 से 10% के बीच में। और 8 से 9 टन हर टैंक में से 6-7 महीने बाद निकाला जा सकेगा। अभी इस सिस्टम को चलते हुए लगभग 1.5 महीना हो चुका है। ये देखिए मछलियों का साइज आपको दिखेगा। सिस्टम में एक सूटेबल डीजी सेट भी लगाया गया है, जो कि एसेंशियल आइटम्स किसी पावर ब्रेकडाउन होने पर उनको बैकअप दे सके। थैंक यू फॉर वॉचिंग।
So this was the video, man.
So this, where is the location of this?
This is in
system
Indore. इंदौर में राला मंडल के पीछे है, एसएस क्रिकेट कम्यून के पास में।
Okay.
So this is also a good business opportunity, new business opportunity for everyone, because government is also giving subsidies on this plant. 40% subsidies for general male category and 60% subsidy for reserved categories and women. Yeah. So this was a small example of what we are doing in the agriculture sector, and using our motto of recycling water and saving the environment. We are implementing these RAS systems. Let's also talk about. I mean, we are at the end of this presentation. Let's also talk about what we have faced as a technology and consultants on ground. I mean, on grassroots. So there are different challenges. We can divide them into technological challenges and administrative challenges. You know that there are many players in the sewage treatment space. There are also different kinds of wastewaters coming in. So, in general assumptions, also we wrongly assume the characteristics of wastewater and design the plant that we have to install either above the what is required or below what is required, over designing or under designing. So, this is probably the cause of more than 50% of sewage treatment plants not working. I mean, in real time. Another cause is bad design and engineering of plants by companies. If you design, I'll give you an example, a small example of Pride City. This is a colony in Bhopal where for a 300 KLD treatment plant, ideally 200 to 250 meter cube of air is required, which can be delivered by a 5 HP or a 7.5 HP motor based blower. The consultant of that project installed a 12.5 HP blower, which was increasing the electricity cost so much that the builder could not operate it. So this is an example of bad design. I mean, basic faults in design and engineering. This should not happen. I mean, then there are different issues like complicated technologies which have the more possibility of operational failure due to human errors, and the lack of training by the companies which install sewage treatment plants to the clients. We have all our training manuals that are present. Probably it takes about 2 to 3 months for one person to get a hang of treatment of the treatment process at any site. This is a grueling, challenging requirement which is there for us. It also impacts our finances also, but we have to do it because we have to show to people that the sewage treatment plants should be acceptable. Sewage treatment plants should be maintained by local people, and everybody can do that with basic training. Basic training is not happening. I'll give you a very simple example. मतलब सभी को मेरे ख्याल से सीवेज ट्रीटमेंट प्लांट्स के बारे में पता है, एरेशन ट्रीटमेंट टैंक्स के बारे में पता है। बहुत प्रेस्टिजियस कॉलोनी है यहाँ पे भोपाल में, मनोज शर्मा जी की श्री गोल्डन सिटी नाम से, वेरी प्रेस्टिजियस, प्रैक्टिकली द मोस्ट प्रीमियम कॉलोनी ऑफ भोपाल. Can you imagine the operator there was mixing chlorine powder in the aeration tanks? अब एरेशन टैंक में आप क्लोरीन पाउडर मिला दोगे तो बेचारे बैक्टीरिया कहाँ जाएंगे? तो दिस वाज अ बेसिक फॉल्ट, मतलब अब ये पता नहीं किसका फॉल्ट है, मतलब दिस इज एक तो टेक्नोलॉजी को आप यहाँ पे बोल सकते हैं कि इट इज कॉम्प्लिकेटेड, जहाँ पे नॉर्मल पर्सन को इफ इज लेस टेक्निकली एनेबल्ड, पढ़ा लिखा नहीं है, तो उसको आप कैसे समझाओगे? तो ये सब गलतियां होती हैं जिनको आइडियली रेक्टिफाई कर देना चाहिए, बट सालों साल होती चली जाती है। मेंटेनेंस में इंडियन पीपल आर वेरी वीक, everybody would accept that. Then another technology challenge is lack of R&D culture in Indian ecosystem. People are not paid for R&D done by them. R&D मतलब प्रैक्टिकली यहाँ पे होती नहीं, यहाँ पे जुगाड़ होता है। जुगाड़ इसलिए होता है क्योंकि कोई पैसा नहीं मिलता है R&D का, right? So what we are trying to do is bring bring everyday research and development into our development of new products. हम लोग के सारे STPs पे जहाँ पे भी हम लोग का मेंटेनेंस है, जहाँ पे भी हम लोग का मेंटेनेंस नहीं है, we try to go there at least 3-4 times a year so that we can understand what are the challenges of the system. एक एग्जांपल देता हूँ आपको। हम लोगों ने एस्टिमेट किया था 250 BOD एंड 550 COD, जिसके हिसाब से हमने एक ट्रीटमेंट प्लांट बनाया था एक होटल में, एंड द वेस्ट वाटर कमिंग इन वाज इक्वल। मेरे ख्याल से दैट वाज अ 55 KLD ट्रीटमेंट प्लांट, but the characteristics of wastewater were very less, 150 BOD, 180 BOD. तो हम लोग we were overdoing our machines there. तो उसको फिर हम लोगों ने धीरे धीरे करके हमारे प्रोसेसेस में लेके आए कि we will test the sewage water first and then design the plant accordingly. So this is just one example. Then comes the administrative challenges. ये एकदम league apart. Lack of training efforts from professionals, okay. Lack of vigilance by government authorities like PCB. The most important is lack of efforts and awareness by common people. आप सभी मेरे ख्याल से कॉलोनीज में रहते हैं, एंड आई एम श्योर बिकॉज गवर्नमेंट का पिछले 20-30 सालों से ये रूल है कि आपको सीवेज ट्रीटमेंट प्लांट्स लगाने हैं, मेंटेन करने हैं अपनी कॉलोनी में, बट आई एम श्योर मोस्ट ऑफ यू वुड नॉट हैव गॉन टू द सीवेज ट्रीटमेंट प्लांट और देखा नहीं होगा कि क्या कौन चला रहा है, कैसे चला रहा है, राइट? नेपोलियन ने बोला था, नीचे एक कोट भी लिखा हुआ है, वर्ल्ड सफर्स अ लॉट नॉट बिकॉज ऑफ द वायलेंस ऑफ बैड पीपल बट बिकॉज ऑफ द साइलेंस ऑफ गुड पीपल. So I urge everyone कि be aware of your surroundings, be very aware of your surroundings, and अगर आप नेचर को प्यार करते हो तो नेचर के अंदर मिलने वाली छुपी छुपी चीजें, जैसे कि सीवेज छुपा हुआ रहता है, इसलिए वी डोंट केयर. सॉलिड वेस्ट दिखता है सामने, इस वजह से सब लोगों को दिखता है कि यार यहाँ पे तो पोल्यूशन है, यहाँ पे तो पोल्यूशन नहीं है. द होल स्वच्छ भारत कैंपेन is made on visible pollutants like solid waste. What about the hidden pollutants, liquid waste? उसके पीछे भी गवर्नमेंट के काफी सारे एफर्ट्स हैं, बट देन देयर इज अ लैक ऑफ कैपिटल फॉर गवर्नमेंट विद द गवर्नमेंट फॉर सेंट्रलाइज्ड एसटीपीज. सेंट्रलाइज्ड एसटीपी बनाने के लिए, सेंट्रलाइज्ड एसटीपी का मतलब होता है कि पूरे एक शहर को सीवर लाइंस बिछा के एक जगह वो सारी सीवर लाइंस को ले जाके वहां पे एक बड़ा एसटीपी बनाया जाए, लाइक इट इज देयर इन इंदौर, इट इज आल्सो देयर इन भोपाल. भोपाल में 8 सेंट्रलाइज्ड एसटीपीज हैं because of the nature of contour of Bhopal. अब यहाँ पे अलग प्रॉब्लम्स आती हैं. कभी आपकी सीवेज लाइन टूट गई, कभी आपके चेम्बर्स टूट गए. इट इज अ फैक्ट दैट जब एसटीपीज बनते हैं अपने 30 इयर्स की लाइफ के लिए बनाते हैं, डिजाइन करते हैं एसटीपीज, वो 30 इयर्स की लाइफ में आता ही नहीं उतना सीवेज जितने के लिए वो डिजाइंड है. All the STPs in India are working at about 50 to 60% of capacities, because sewage collection is a big part, sewage transportation is a big part, and lot of losses happen there, which is why there is a huge hue and cry on focusing on decentralized sewage treatment plants. हर एक कस्बे में, हर एक कॉलोनी में अगर आप ट्रीटमेंट प्लांट्स लगाएंगे तो there will be no need of centralized sewage treatment plants, right? And this will create different kinds of challenges, that you need good manpower which are maintaining the STPs, but then it will also create opportunities for young people who want to get into the sector, right? These are some challenges, and I would like to hear from all of you, what kind of challenges have you faced related to wastewater? मतलब let us figure out क्या challenges हैं और उनका क्या solutions हैं together. Uh, Anybody has any points, has any inputs on this?
Yes, please participants come forward and share your view regarding any challenges if you have faced. So once I had gone to a wastewater treatment plant at Indore, but I really found that although there was some treatment being carried out, but it was not up to the mark that the water being discharged was to a level that can be that should be discarded into any other water bodies. That was the most drastic experience which I had, that I couldn't ever imagine. As theoretically, we always expect that the treatment plant should work in a proper way, but when we go to a practical location and we see the problem, it is not working that much efficiently. And ultimately, that wastewater, whatever it is getting added into the water bodies, is again polluting.
Simple case of ignorance by operators, simple case of ignorance by vigilant authorities, simple case of ignorance by the technical people. I'll give you another example. सीहोर का सीवेज ट्रीटमेंट प्लांट बना हुआ है बहुत अच्छा. आई थिंक इट इज 8 mld ट्रीटमेंट प्लांट. पूरे सीहोर का सीवेज वहीं पे आता है एंड इट इज गेटिंग ट्रीटेड. Now the company which was supposed to commission the plant took about 9 months to commission the plant, 9 months to bring results out of that plant. It takes us about 15 days to do that in a small STP. This is where the advantages of small STPs come when compared to big STPs. जब 9 महीने के लिए उसके डिजाइन लाइफ ही प्रैक्टिकली 30 साल है, 1 साल तो उसने वो ट्रीटमेंट के लिए निकाल दिया एंड उसको वैसे भी 20 से 25% ही आ रहा था वेस्ट वाटर. These are big challenges on ground, big challenges.
So we have opinion by Vignesh sir. He has said that problems of treatment in rainy season and specifically capacity based improper management of sludge.
Yes, rain plays a spoil sport, no doubt, and there is no going around rain. Rainy times पे treatment plants में practically 3 to 4 times of sewage आता है per day. You have to keep your plants up to date and design them in such a way so that they can handle such surge loads. क्योंकि जरूरी नहीं है कि ये 24 घंटे आए, हो सकता है सारा का सारा पानी 1 घंटे में ही आ जाए. So what you have to do is you have to stop your inlet, stop your sewage treatment plant being flushed by rains. क्योंकि simple rains will cause only one thing, flushing out of our biomedia, जिसको बनाने में another 15 to 20 days लग जाएंगे, right? And it is a huge effort. It is a huge effort for anyone. तो रेंज का मैनेजमेंट आपको लेके चलना पड़ेगा. यू शुड हैव बाईपास अरेंजमेंट्स, यू शुड हैव बाईपास अरेंजमेंट्स, पंपिंग बाईपास अरेंजमेंट्स आल्सो, व्हिच वी यूज इन आवर प्लांट्स. अनदर सजेशन वाज बैड मैनेजमेंट ऑफ स्लज. इट इज वेरी ट्रू. इंडिया में जितने प्लांट्स हमने देखे हैं सब जगह पे स्लज मैनेज ही नहीं हो रहा है. स्लज को सिंपली, मतलब इंडियंस आर वेरी वीक टेक्निकल वाइज ऑल्सो. मतलब आप अगर किसी अनपढ़ आदमी को बिठा देंगे एसटीपी मैनेज करने के लिए तो उसके वैसे ही एसटीपी थोड़ा सा कॉम्प्लिकेटेड लगता है. वो स्लज ट्रीटमेंट और कॉम्प्लिकेटेड प्रोसेस है. तो आई फील कि स्लज ट्रीटमेंट के लिए बड़ी बड़ी मशीन्स के बजाय सिंपल स्लज ड्राइंग बेड्स होने चाहिए, जहां पे एक सिंपल स्लज को ट्रांसपोर्ट कर दिया और वहां पे वो सूख जाता है एंड उसको उस तरीके से डिस्पोज कर दिया. This is my personal opinion. It is also there in IISER, ISER Bhopal. यहाँ पे इन्होंने बड़े STP लगाए हुए हैं and the person who is in charge of civil there, he prefers sludge drying beds over mechanized sludge treatment systems. बहुत सिंपल बोलते हैं यार हमारे यहाँ पे कौन वो वॉल्व खोलेगा, कौन वो पंप चलाएगा और उसको कंप्रेस करेगा, कहीं भी कभी लीक हो गया तो कोई छुएगा नहीं उसको. स्टिग्मास रिलेटेड टू सीवेज, राइट? इससे अच्छा स्लज ड्राइंग बेड लगा दो, सिंपल उसके ऊपर स्लज गया, सूख जाएगा, हम उसको अपने पेड़ों में डाल देंगे. वी शुड ट्राई टू मेक simpler things rather than complicated things.
And also, sir, I feel that there is a huge gap between theory and practical. So
Yes.
we should adopt a theory from the practical which is being carried out, and we should rather redesign our courses according to practical applicability.
Exactly, which is why collaboration of different technology people is very much necessary. आप अगर कुछ मुझे 2 पॉइंट्स बताएंगे, मैं अगर आपको कुछ 2 पॉइंट्स बताऊंगा, तब जाके अपने दोनों का डेवलपमेंट होगा, राइट? Collaboration is also weak in India. It happens, but it happens less, I believe.
So everywhere there is a lot of political issue into
Yes.
everything.
Yes.
So we have another opinion by Venkatraman sir that he says that pumping stations are properly maintained.
Mhm.
So is it maintained or not maintained?
Ma'am, I have seen very less pumping stations. All of them were in not operational stages. In Gwalior, I have seen. In Sihor, I have seen. कोई operational stage पे नहीं था. Because pumping stations are very remote stations. वहाँ पे कौन देखने जाए? Automation होता नहीं है pumping station में. It is always automation होता है तो main sewage treatment plant में होता है. तो there are other challenges for pumping stations. Another reason for shifting into decentralized treatment plants.
So I would like to ask one more thing. I think I'm very curious about all these things.
Yeah, please.
Sir, is there a possibility of training for the upcoming students? Like if they can get trained into all these things, probably they will get a better opportunity of getting into field and this entrepreneurship sort of thing. So do you
Definitely.
also train students?
I do not train students. I train people who come in our company. But yes, we can do that. I mean, we can do field visit exposures. We have around 15-20 treatment plants in Indore. We have more than 80 treatment plants in Bhopal. I would be happy to organize such trips.
Thank you so much, sir. That was a wonderful interaction by Harshit, sir. And if any of the participants are willing to ask any questions, you're most welcome. Or it's almost time that we should conclude this session.
Yeah. I just
So,
have one last slide, if you permit me, madam.
sure, sir. Definitely.
So, these are just some volunteer activities which we do. As you mentioned, हम लोग training करते हैं कि नहीं करते हैं. So I was personally a part of Global Shapers Community Bhopal Hub, which is a initiative of World Economic Forum, and I had the privilege of representing Bhopal in Geneva in Switzerland as a delegation of Global Shapers. ग्लोबल शेपर्स का इज अ यूथ ऑर्गेनाइजेशन. इट इज अ वॉलंटियर ऑर्गेनाइजेशन जहाँ पे आप अपने हिसाब से अगर अपने सिटी को बेटर देखना चाहते हैं टुवर्ड सस्टेनेबल डेवलपमेंट गोल्स, तो उस तरीके से हम काम करते हैं. Two projects which I have initiated are Harvesting Heavens. Harvesting Heavens is a simple rooftop rainwater harvesting project जहाँ पे हमने खुद ने बहुत सिंपल फिल्टर बनाया है, वेरी सिंपल फिल्टर, स्क्रीन फिल्टर, जिससे जाके जिसे रूफटॉप रेन वाटर वो फिल्टर से होके डायरेक्टली अपने बोरिंग में डाला जा सकता है टू रिचार्ज द ग्राउंड वाटर. अ वेरी इंटरेस्टिंग केस वाज, हम लोगों ने फर्स्ट प्रोजेक्ट जब किया था भोपाल में, एक हिंद फार्मा करके एक इंडस्ट्री है, वहां पे हमने ये हार्वेस्टिंग हेवेंस का जब प्रोजेक्ट किया, उसके बाद उसके पहले करीब 10 से 12 टैंकर्स, 10,000 लीटर वाले टैंकर्स इनको मंगवाने पड़ते थे हर समर्स में, क्योंकि इनका बोर फेल हो जाता था. समर्स में इतना पानी नहीं रहता था बोर में. उसके बाद से आज 3 साल हो चुके हैं, उनको 3 साल में कभी भी टैंकर्स नहीं मंगवाने पड़े. उनका वो उनके खुद के बोर से बिकॉज ऑफ रिचार्जिंग उनका पानी का यूटिलाइजेशन हो जाता है. सो दिस इज अ वेरी एनकरेजिंग थिंग फॉर अस आल्सो. प्लांट एज, प्लांट एज एक बहुत सिंपल सा इनिशिएटिव है जहां पे हम लोग, जितने भी लोग हमसे कनेक्टेड हैं, उन सबको बोलते हैं कि आप आपका जब भी बर्थडे हो, ask us, we will assist you in planting trees equal to the number of your age. I am 30 years old. I have been planting the trees since the last 3 years जब से plant चालू हुआ है, and up till now we have planted more than 400 trees in the last 2 years. Imagine if a person in his lifetime of 1 year to 60 years, He can plant around 1800 trees if he takes the resolve of planting trees. If even if 1% of the Indian population does this, we can plant 23.4 billion trees. Imagine in the 60 years. So this is a big potential. This is a big message. Everybody should do that. Another volunteer activities that we do is with Narmada Samagra, which was an NGO founded by late Shri Anil Madhav Dave sir, who was the Minister of State for Environment and Forest and Climate Change. We made a very simple slow sand filtration based drinking water filter. आजकल बहुत सारे filters आ चुके हैं, स्वच्छ filter, टाटा का filter, RO systems and all. अभी भी जो अपने अपने यहाँ पे नर्मदा का पानी आता है, सब लोगों को पता होगा, it is based on slow sand filtration system. स्लो सैंड फिल्टर बेड्स होते हैं, यहाँ पे ऊपर से पानी आता है और फिर फिल्टर होकर नीचे जाता है. तो इस टाइप का एक छोटा सा फिल्टर बनाया था. I'll show you photograph of that. This is a very small filter. एक बकेट में हमने बनाया जिसमें सैंड है, चारकोल है और पेबल्स हैं, और बहुत सिंपल तरीके से इसका this can take out 20 liters of water in 1 hour. We have done this in association with नर्मदा समग्र, और नर्मदा बेल्ट में जितने भी विलेजेस हैं और पंचायत हैं, यहाँ पे सब में क्या बोलते हैं, इनके वॉलंटियर्स प्रेजेंट हैं. So I personally have trained more than 100 volunteers to build this product. आप देखेंगे एक और, या आप राइट हैंड साइड पे देखेंगे, दिस वाज द पायलट स्केल जो हमने बनाया था. एक सिंपल ड्रम में यूज करके 500 रुपए के अंदर ये फिल्टर बन सकता है. कोई भी स्कूल के लिए, कोई भी घर के लिए, इट इज वेरी फीजिबल एंड इट कैन बी मेड इन लोकल मटेरियल्स. So this was a small filter that we created. हम लोगों ने volunteers को train किया. Volunteers आके अपने गांव-गांव में इसको use करते हैं because there is a problem of turbidity in groundwater near the Narmada belt. It is very good in removing turbidity and iron-based sediments also. So this is one initiative that we did. We have also established community solar water treatment plants based on slow sand filtration technique again. In Adarsh Gaon of Anil sir, Jahanpur and Ramnagar. Also, MLK Waste Management is also empaneled consultant for Recirculating Aquaculture Systems in India, and we have been awarded this certificate by NFDB, National Fisheries Development Board. I personally have won the Water Heroes Prize by Ministry of Jal Shakti in October 2020. These are some awards and accolades that we have done. There are some photographs. हार्वेस्टिंग हेवेंस का ये फिल्टर आप देख सकते हैं पीछे लगाया हुआ है हमने, ये वन ऑफ द फोटोज ऑफ प्लांट एज. सो आई जस्ट conclude my slide with the impact we are doing towards sustainable development goals. We are working towards clean water and sanitation, industry innovation and infrastructure, sustainable cities and communities, responsible consumption and production in our RAS, climate action in our STPs and RAS both, life below water with our aquaculture interventions. So this was all about what we are doing at MLK Waste Management and what I am doing personally. Thank you, and I am open for questions.
Thank you so much, sir, for this wonderful and lively session. We almost thought that we reached all the areas which you discussed on. It was a wonderful and enlightening session, sir.
Thank you.
So I don't see any questions from the participants' side. If there are no questions raised, then shall we conclude this session? Or if you want to ask, you're most welcome.
I would be. I like interactive sessions, and whenever people ask questions, there are always new ideas coming up. So that would be great.
Definitely, sir. I think in the meantime, when we had the topics touched, that time also we have certain questions that were raised, and we definitely you addressed them very nicely. Thank you so much, sir, for this wonderful session regarding the water treatment and this innovative recirculating system which you have been using in the various areas for the aquaculture. So I thank you, sir, on behalf of the Civil Engineering Department at IPS Academy. It was indeed an honor, privilege, and a wonderful session by you. And we hope to seeing you in future in person sometime.
Thank you.
So definitely meet us and give us an opportunity to interact with you whenever you come to Indore, sir.
Sure, sure. इंदौर में मेरा ससुराल है तो मैं आता रहता हूँ.
Please, sir, let us know.
Sure.
Thank you so much, sir.
Thank you.
And
Thank you so much. Thank you,
thank you so
everyone.
much. So, indeed, the privilege was all ours. Thank you, sir.
डिजिटलाइजेशन सिस्टम है सब पकड़ा जाते हैं.
So this was a wonderful session by Harshit sir. He is the managing partner of the MLK Waste Management, and we are now very well aware of his activities, the work he is contributing towards the restoration of different water bodies, wonderful work which he's been doing regarding the sewage treatment plants and the aquaculture recirculating systems as well. So the next session is now scheduled after a lunch break. That will be at around should be around in say half an hour. I hope to see you again soon with the next session also. Thank you so much to the participants. Looking forward to see you again after the lunch break.
Thank you.
Thank you, sir. Sir, I'll be sharing my screen for the introduction, sir.
Yeah, please.
Sir, is my screen visible, sir?
Yes, I could. Well,
Shall I start, sir?
yes, please.
A very good afternoon to all the participants of this AICT sponsored 1 week online short-term training program on water quality complication, restoration and environmental conservation of existing water bodies, Module 2. And we are glad to have with us Mr. Dilip K. Bera, sir. He is an environment sustainability professional with more than 26 years of experience in the areas of environmental management and sustainability. His main areas of expertise are air pollution control, wastewater treatment, hazardous and chemical waste management, ESG, statutory compliance, environmental audit, environmental social impact assessment, ISO 14001, waste minimization and utilization, hazard identification, hazard analysis, risk assessment and control, job safety analysis, safety audit and inspection, OSAS 18001, environmental and industrial hygiene monitoring and analysis, and HSE trainings. Bera sir is a graduate from National Institute of Technology and a postgraduate from Indian Institute of Technology, Delhi. He is also having postgraduate diploma in Industrial Pollution Prevention and Control from National Productivity Council of India, Advanced Diploma in Industrial Safety from Maharashtra State Board of Technical Education, Executive Management Program from Indian Institute of Technology, Bombay. He has worked as a production executive in chemical process industry. Then he was associated with organizations like the National Productivity Council of India, New Delhi, and Environmental Management Center, Mumbai, in diverse areas of environmental management consulting. Later on, he worked with leading corporates in industrial sectors like the infrastructure, construction, real estate, steel, power, port, petroleum and oil gas regarding environmental management and sustainability. So he has in all more than 26 years of experience, and he has published and presented papers at national and international workshops also. We are glad to have you with us today, sir, and I'm thankful on behalf of the Civil Engineering Department at IPS Academy Indore that you accepted our request and could manage to take out time from your busy schedule and enlighten us, sir. Thank you, sir. I request you to please take over the session.
Thank you, madam. Thank you so much for let's get the slide. Could you able to see my slide?
Yes, sir, I can see it, sir.
Yeah. So,
sir, it is not in the full screen mode, sir.
Yes.
Yes, sir, now it is. Yes.
Very good afternoon to everyone. Am I audible to all?
Yes, sir, you are audible, sir.
So, now in next 1 hour or so, I will be discussing about wastewater treatment technologies, reuse, recycle, and this, your topic is basically water quality, restoration, and environmental conservation of existing water bodies. So, with this context, existing water bodies. So, my topic will be on technologies primarily, and then water conservation and water audit. For any water bodies or any other ecosystem restoration, it has a broadly two angles, two aspects you can say. One is you end of pipe, I mean at the end you work, and another is you work in upstream. You do the intervention, technological intervention, management intervention at the upstream itself, so that it becomes easy or much more effective and sustainable to do all the conservation efforts what you are putting in the end. So this is managing the upstream, also upstream environment or contribution by the upstream activities, activities in the upstream, say industrial activities, it could be municipality, it could be the commercial, which is giving the pollution load to the water bodies. So we have to, holistically, we need to address both upstream as well as focus on the water bodies itself. So my presentation primarily will be focusing on managing the upstream, means from where, which is the source of pollution load which is entering into the water bodies, and how we can do the management intervention, technological intervention that will sustain the efforts you are putting in the downstream, which is your on the water bodies. So with this background, let me now move ahead. So I will be taking you through like water audit elements, how to do the water audit, and what will be the water audit report structure, systematic report structure. Then I will be also spend some time on water conservation, how systematically we can take the water conservation studies and effectively come out with what are the water conservation measures, technological intervention. Obviously, then wastewater treatment, and those treatment should lead to recycle and reuse. And obviously, third parties, I will be spending some time on latest technologies on wastewater treatment. Okay, now let me first take the first topic, which is the water audit. Basically, purpose of water audit is to do the source to sink assessment of water sourcing, from where water is coming, how you are treating the water and usage pattern, then quantity of usage, wastage, all those matters, then wastewater collection, treatment, and disposal. So this end-to-end source-to-sink assessment of broadly these aspects are part of the water audit. So why we need water audit itself? It determines the volume of water loss in the distribution system, determines the cost to it, and it identifies and gives a detailed profile of distribution network, distribution system, who are the users, then classification of users, like who are the heavy users, who are the small volume users, like that, and facilitates easier and effective management of resources. Ultimately, I will not go through all points one by one. Ultimately, objective is to it give a realistic understanding and assessment of the entire effectiveness and performance of the water distribution system and water utilization efficiency. And ultimately, it should give the cost effectiveness to the entire system and to the management. And it is an ultimate step towards water conservation. So unless we find out where it is getting lost, where it is getting unproductive use, we cannot make any intervention. So it is a very important, crucial step towards water conservation. Water audit scope, obviously, it includes broadly these aspects: assessment and records of raw water, existing water storage system, raw water treatment. You know, even for domestic use or industrial use, we cannot just as it is use the water. We need to provide some treatment for the purpose where we are using. Then process mapping and development of water balance across the entire system, identification of consumption pattern, metering. Metering is a crucial aspect in water distribution system and use. Then assessing prevailing wastewater generation, segregation, collection, treatment, disposal, including what are the limitations, how effectively it is getting done. And obviously, it should come out with how we can do reduce, reuse, and recycle towards water conservation with cost benefit analysis and what will be the investment towards it. For example, just scope, it starts with water storage, metering, assessment. These areas we need to look into very detailed and carry out the analysis and come out with recommendations towards improvement. So water audit methodology basically primarily consists of these 6-7 steps. Basically, you need to organize, plan and organize, which require a quick walkthrough survey. Then primary data collection, conduct a detailed survey monitoring, which includes water sampling, analysis, metering, measurement, analysis. Then very crucial step is, out of this exercise, you need to find out what will be the water conservation opportunities and carrying out the cost benefit analysis, and finally systematically report the findings of the water audit study. So what I have done is I have just what will be the steps broadly into 3 stages, basically: pre-audit stage, audit stage or audit phase, and post-audit phase. So what are the steps involved is identified and elaborated here. Like before, means pre-audit stage, you need to do walkthrough survey, informal discussion with the personnel involved in the water distribution, treatment, and entire exercise. Conduct brief meetings with persons who are in charge of those areas, which will give a idea how to plan a water audit, how much resources you require, what all equipment you require to do the measurement of volume of water, or how much, what will be your wastewater measurement and monitoring plan. So what resources you require, or how many manpower you require to do the entire exercise, what all instruments, everything. Yeah, so this planning stage is quite crucial. Then actual audit phase, and in planning stage you will find out the action plan, how you will do it, and next comes the audit phase. So it is data collection, process, identifying the process flow, how water is flowing, or entire distribution system or use. You need to find out where it is, that is called process flow diagram, where it is getting used, what are the utilities, what are their capacity, how effectively they are running, like water bill, water consumption pattern. Every data we need to collect, or we need to generate data, analyze, and uh, discuss, so that we can find a clue out of it, where lies the opportunities for water conservation. Then survey, monitoring, and obviously water use pattern. And next step is basically identification and development of water conservation opportunities, which requires detailed review of ideas suggested by personnel concerned, use brainstorming and discussion with team involved in utilities, then carry out the cost benefit analysis. In subsequent slide, I will go little elaborated. I will elaborate on water conservation, how to find out systematically water conservation opportunities. Then obviously reporting and presentation to the management. Then post audit. Then post audit also there are few actions involved, like implementation and follow-up action. Just by identifying opportunities will not serve the purpose, so it requires implementation and follow-up, and find the effectiveness of the implementation. And obviously water conservation opportunities, you have made the project schedule, so monitor the project schedule, monitor the performance, and see the effectiveness of implementation and follow-up and review activities. So I will now just present you typically what will be the contents of a water audit report. So it just slide speaks for itself. Objective is to systematically present the water audit report. Now this water audit, it's such an important tool. It can be done at industry level. It is periodically done. Even very recent past, CGWA, Central Groundwater Authority, has already issued notification that industries need to carry out periodic water audit in their operations. The water audit could be done in a housing society, in a big institutional educational complex with so many hostels and other facilities, quarters. So it will give a opportunity towards effective and efficient utilization of water, and it will lead to water conservation and conservation of this crucial resource, which is water. Now I will come to first water conservation, which is how to systematically find out water conservation opportunities and studies. Then I will move to treatment part of it. Now, as I mentioned, to systematically do water conservation, now it is part of water audit. You have done all work. Now, how you will find out water conservation opportunities? So you need to have a detailed plan. These are the 6-step process: initializing, analyzing the process steps, generation of water conservation opportunities, feasibility studies, implementing and monitoring, and sustaining those water conservation program and opportunities. Now, this step 1, if we break down into various tasks like planning and organizing, it involves team, formation of suitable team with experience and diversified team, identify the process steps which are the involved and identify waste streams, identify and select wasteful process steps, select audit focus, where even in we have done the audit, but some area which require special audit and much focus. So identify those areas where lies the opportunities. Then analyzing process steps, how we will analyze, prepare process flow chart, collection of baseline data, water balance, assign cost to waste streams. That is very important step. Unless we assign cost to any resource, we will not give enough value to that, importance to that. Review the process, identify the waste causes. Step 3, generation of opportunities, identifying opportunities, and out of say 10 opportunities, all may not be of same priority or all may not give the same kind of return. So prioritize and rank them which you need to take up first or implement the first. Here I would like to mention one thing. This thing is that these water audit, water conservation opportunities, already I have mentioned once, that it is not only limited to the industries or industrial setup. It is equally important and equally applicable to all other setups. I'm repeating, it is for housing societies, it is for municipalities, for big institutions like IITs or other colleges or universities, hostels, canteen, every setup is there, or colony for the faculties and other support professional. So it is relevant for every small, big organizations, institutions, including industries, even in offices, even in corporate offices, and as well as manufacturing location. So everywhere, this same tool with different focus, you can find the opportunities and contribute towards water consumption, water conservation, and which will lead to like our saving our water resources, water bodies. Next step is feasibility analysis, which includes technical feasibility, economic feasibility, environmental feasibility. Select the right solution for implementation. Then prepare implementation plan. Next task is implement the conservation opportunities solution. Then monitor and evaluate results. Then sustain those solutions. It's not a one-time process. We have to sustain it and we have to see a very long term. Then identify another audit focus and select another wasteful process and continue with the effort. It's an ongoing process. Now I'm just spending a couple of minutes here. You see, all our efforts towards water conservation requires kind of an integrated strategy, holistic approach. Like objectives with the following objectives is basically conserve water, reduction in water consumption, achieve water efficiency, prevent water pollution, and control water pollution. Those crucial 4 pillars we need to see in a holistic way, integrated way, and it requires like tiered approach. It requires tiered approach by the all stakeholders concerned, whether it is industry or other institutions are concerned. Basic approach is first tier is comply with relevant national, international acts, rules, standards, guidelines. As on today, our country, India has very good, relevant guidelines, standards by CGWA, CGWB, CPCB, Central Pollution Control Board, and various industry-specific guidelines and standards are available. For building setup, institutions, we have National Building Code. So it gives a very good specifications and guidelines. How much water consumption, what will be the faucets used in home or industry or in institutions. So, and resource efficiency. Nowadays, all water used like tap, valve, everything, even hand shower, everything. Now water efficient uh, equipment, valve, everything is available in the market, which gives higher efficiency. So resource efficiency. Third tier is go beyond the factory boundary. Means I use the word factory from industrial context, but it is not the factory per se. It is your institution boundary. So go beyond the boundary means you need to now look forward nearby community where these water bodies are coming, or you are using the water, how you can contribute towards upgradation or upliftment of the water bodies surrounding your institutions or premises, or what you can do for the groundwater recharge or improvement in the groundwater table. So you means we need to go beyond our boundary, beyond the boundary of our institution. Institution could be anything. It could be a school, society, any big office complex or an industry. Then integrate and embed with business process. Every institution has a process based on which it is operating. So in their decision making, it should be integrated, and which will lead to conservation of water. And one more thing, water is nothing but energy. If you conserve water and use productive way, efficient way, it will lead to your energy efficiency. Because water, where suppose drinking water, I'm sitting my home using drinking water, using for bathing, everything. Water is not coming free. It to reach to my flat at the 10th floor, there is a huge amount of energy is expensed. It is coming from some river to water treatment plant of the municipality. From municipality is pumped out to the society storage tank. From there, it is again pumped and distributed to the entire. Say there are 10 apartments or 50 apartments distributed, and tap water what I am getting, it's not free. It has already huge amount of energy is expensed so that I could get the tap water from my tap. So water is energy. So it has a direct benefits of conservation of environment, conservation of crucial resource like water, and indirect benefit is also we are conserving the energy, which is again coming from fossil fuel or non-fossil fuel resources. Indirectly, we are also saving the Mother Earth in terms of sustainable utilization of all our say fossil fuel or other energy resources from where we are getting the electricity, and indirect also that will in turn will save or reduce the greenhouse gas emissions. Now you see the link and holistic view of it. It's not the simply water what we are drinking or using. You see the nexus. You see the how many other aspects, dimensions are involved into it. So that's why I want to communicate here. We need a integrated strategy and look far beyond than the what problem we are seeing, which is very obvious or small. So integration in each stages of business, starting from conceptualization to design stage, engineering and construction commissioning. It could be a factory building, it could be an office complex or a small school. Everywhere principle remains the same and operate and maintain. A simple example, selection of water efficient process, equipment, green chemistry, I mean much environmentally benign chemicals, water efficient standard operating procedure, green procurement means procure recyclable material. So you need to have a procurement strategy, sustainable sourcing of water. From where water we are sourcing, that requires again a sustainable view, sustainable approach. It is called something we do in industries. Some industries do like it is called water sourcing risk assessment. From where we are sourcing the water for the use, what are the risks involved into it, how long it will sustain, what is the sustainability of that water body, from where we are sourcing the water. Water sourcing risk assessment, even software tools are available. You can do for any location, say Delhi, for a particular section. You can do modeling and what are the water body source, and you can find out the risks. What are the risks involved in withdrawing, say, groundwater, or you are drawing from some river. So what are the risks involved? So it is called water sourcing risk assessment, and software tools are also available. Now, one example I am giving, already I mentioned about groundwater recharge. So, rainwater harvesting and groundwater recharge also plays an important role in restoration, conservation, and restoration of water bodies. You might be knowing this kind of figures. What I want to say here is, again, CGWB or CGWA, they have a very good guidelines how to conserve, how to do the rainwater harvesting. Just it has two aspects. One is rooftop and all around the house, all around the building or factory premises. And rooftop can be collected from the rooftop, could be taken into any open well, and you can put into the recharge. Even surface runoff into a percolation pit for the recharge. So just I will give you one a snapshot of it. Like a building, office building, you can collect from the rooftop and channelize through pipeline and filtering chamber, and you can put into the percolation pit, and it will or a recharge well, and it will help in improving the groundwater level in that area and surrounding. And this recharge pit, percolation pit, it has a very simple design. Like what you see the design cross section of it, like coarse sand, gravel of which size, and then boulder and diameter. So it can be designed in a very simplistic, simple guidelines are issued by CGWA. Now I'm coming to the treatment technologies, water and wastewater treatment technologies. Now, why we need treatment? Basically, you need to have a specific quality to achieve the quality standard. You need for water, drinking water has a specific standard. Water you are using for bathing, a specific standard. Industrial application has a different standard. So, for that purpose, and the raw water you are getting could have a different standard. So you need to make it suitable for your use. It has to be treated. So that requires treatment. So treatment process broadly, it can be, you already might have learned this treatment process. One is physical process, chemical process, biological process. Just I'm giving one example, like simply gravitational settling, which removes the settlable suspended solids. It's a physical process. It does not require any chemical reaction to be involved. There are processes which is chemical process called chemical process. Typically, it requires oxidation, reduction, this kind of process called chemical process. Then biological process, which is one example is activated sludge process. Biological process is nothing but adaptation of what is happening in nature in a very controlled environment for treatment of wastewater. I will come into detail in the next slide. Now I'm elaborating it one by one. Physical treatment process to begin with. These are called physical unit operations. Something called this unit operations. These are called unit operations. It does not require any chemical reaction or conversion from one element to another. So this is simply physical properties of the pollutants and water is utilized to clean or treat the water to a suitable standard, suitable quality. It starting from it is flow metering, like flow measurement. These are called unit operations. Screening, removal of pores and settlable solids, comminution means grinding. You see, water is coming out of from the river or it is pumped out from the lake, so it will have lot of settlable solids, and you need to measure also. So logically you think or other way, if some stream is entering into your existing water bodies, so you need to do need to set up this kind of unit operations so that your treatment scheme could be finalized. You see, treatment process, it is not a single treatment unit. It is a combination of lot many units and processes put together is called treatment system. So these are one elements or I should say unit operations which will be there in series and put together is called treatment system. Then flow equalization, mixing, flocculation, sedimentation, flotation. So just I have given the purpose or application where the unit operations are used. In a gas stripping, like a removal of dissolved gas from liquid. Now, chemical treatment. Before I move forward, I would request if any question you can stop me. We can discuss. Then we can.
If the participants,
yeah.
Yes, if the participants have any questions, you can even type in the chat box, please.
Okay, that can be a very good option also, please. So that we can, in the end, you can type or you can, in the end also, you can note down now, you can discuss in the end, or you can type it as you wish. I will leave it to you, or you can stop me in between also. Now, moving forward, first is physical treatment process, then chemical treatment process. These are could be chemical precipitation, absorption, disinfection, oxidation, reduction. These are the basically in falls under chemical treatment process. Like it is used mainly for treatment of dissolved metals, removal of dissolved metals, heavy metals from the water, removal of organic compounds, color, killing of pathogens, bacteria, then oxidation reduction again, say cyanides, chromium treatment, hexavalent chromium. For this kind of pollutants or contaminants, we need to take up these chemical treatment processes. Now, I will spend more time on biological treatment process, which is, as you know, based on the nature of oxygen utilization. It is basically there are four kinds. One is called aerobic process, biological treatment process. Some are called aerobic process, some are called anaerobic process, some are called facultative process, some are called anoxic process. So there are broadly four kinds. So aerobic process, basically this aerobic process name itself suggests it requires these microorganisms. As you know, let me also give some clarify. This subject is means water treatment within the environment. It's a quite a big subject. Means in a 1 hour or couple of hours, just I've tried to summarize and trying to explain it, but it's a quite a big subject and quite a diversified subject. And with this biological treatment process, it is called microbiology. So that understanding of microbiology, or that even microbiology is taught in as a that requires also few quite a few lectures to understand the microbiology. So it is here in biological treatment process, basically microbiology, that subject or that learning is used for treatment of wastewater. So aerobic process, these microbes or microorganisms, they require oxygen for their growth, and in the process they utilize the carbons, organics in the wastewater, and they convert into water, methane, carbon monoxide, and into gases, and ultimately that dissolved organics. In terms of, in my last session, I was discussing about BOD, biochemical oxygen demand, chemical oxygen demand. So they consume, basically convert those organics, dissolved organics, into byproducts like methane, carbon monoxide, water, carbon dioxide. So these microorganisms uh, require oxygen. So this is the basic principle of aerobic process, which again divided into two broad categories. Another is called suspended growth process, and other one is attached growth process. Again, this classification, suspended and attached growth, it is how microorganisms uh, behave, where they stay and grow. And so accordingly, it is divided into suspended growth process and attached growth process. So suspended growth process, again, it has lot of variations: activated sludge process, aerated ponds and lagoons, sequencing batch reactor, aerobic digestion, extended aeration system, waste stabilization or oxidation ponds. So, and also there are a lot of improvisation and improvement within this basic principle of operation. So, lot many variations and improvisation and technological advancement has taken place in those areas. But basically, these are called suspended growth process. And here I would like to mention this lagoon, aerated ponds, lagoons, then waste stabilization, oxidation ponds. These are the processes or are used for restoration or of water bodies, the big size ponds, water bodies. So these technologies are used for treatment of if any water body is already polluted or getting polluted, then this kind of treatment technology extend, like waste stabilization ponds, oxidation ponds, aerated ponds, lagoons. These technologies are used for restoration of water bodies. Another is attached growth process. Here, microorganisms on the surface, they grow on the surface, and earlier one suspended, they remain suspended in the effluent itself. So this is the basic difference. Like attached growth process, this has again various variations like trickling filter, roughing filters, rotating biological contractors, and also there are lot many advancement in those areas. Now, you might have, if you go to any river bank or even sea beach where lot big size concrete or stones are there, you will find a one layer of slim layer of growth green color you will find on the surface of these rocks. Those are the nothing but typically growth of microorganisms, and trickling filter or this attached growth process is not typically looks like the same. And if you see in a river or in a sea beach with a rocky sea beach, you will find this kind of growth. These are called, just citing the example, these are called attached growth process of biological treatment process. Now coming to anaerobic, these systems does not require oxygen. This set of microorganisms does not require oxygen. In absence of oxygen, they can grow, they can eat away the organics carbons present in the effluent. Again, it has a two variety, broadly suspended growth and attached growth, and there are various configurations and variations are involved. Aerobic digestion, anaerobic contact process. It is called upflow anaerobic sludge blanket reactor, anaerobic lagoons. These lagoons again kind of a restoration of water bodies kind of applications. More of a utilization of natural system. Then attached growth process. Again, it has a quite a few variations like anaerobic filtration, expanded bed reactor, fluidized bed reactor, not many variations. Then one more out of aerobic, anaerobic, another is called facultative. Means here you will find there are set of microorganisms which can survive in absence of oxygen, also with oxygen. So it is a mixed properties. So these are called facultative process, and it is like facultative lagoons. So this is not so prominent, but mostly is used is aerobic process and anaerobic process. Another is anoxic process, which is nothing but the denitrification process. We might have all we have learned the denitrification process in for biology. It is typically same process, and very specific cases this application is used, an aerobic process. Now I will spend some time. As you know, there are a lot many varieties, a lot many improvisation, development, and a lot of research work is going on. Advancement is taking place. Now, thing is that how to select your treatment system. What are the criteria? What are the considerations you need to take care so that you set up a system. It is a combination of various treatment unit process, unit operations and process. So which will give you the ultimate result, which is the desired quality of the water. So degree of treatment needed to bring the quality of raw wastewater into a permissible or acceptable level of treated effluent. So what kind of treatment, what degree of treatment you require, that is the key criteria, one of the key criteria for selection of system. Then ensure that final effluent is either safe for disposal or acceptable for specific reuse and recycle. So that we have to ensure. Availability of funds. You need to have a budget for that. Accordingly, you need to select a treatment system. Otherwise, funding is a big issue. Availability of land at treatment site. whether you need to some treatment technology, some technologies require huge amount of relatively large amount of land footprint. Some are very compact and packaged, which require very less footprint. So that where your problem lies, I mean, where you need to, in which location you are putting up the plant treatment system. So land availability is crucial. And topography of the land. It is a plain flat land, or it is a like hilly terrain like Simla or somewhere where you will not get a sufficient land which is flat. So that also is crucial consideration. Then availability of suitable equipment, availability of skilled manpower in operation and maintenance. Nowadays, lot of instrumentation and automation has taken place even in treatment run operation of the treatment plant. So you need a skilled manpower, technical backup, so that you can run the treatment plant. Otherwise, these treatment plants are very sensitive. Some, what I have explained, some are very sensitive to the shock loading, means sudden change in load of pollution load. So accordingly, considering these criteria, accordingly you have to choose and select the exact process according to your like variables, where you need a don't have a skilled manpower available. So you need to select a system, a treatment system and process where you don't require a very skilled operator. So it is a robust system, so it will take care. So accordingly, your treatment process, system, design, everything has to be done accordingly. So selection is very important for all cases, whether it is for industry level or for restoration of water bodies. So selection of technology is important, considering those factors to consider. Now, this treatment process, theoretically, it is divided into three, basically, based on water quality expected to produce. It is divided into, it is basically terms like that: primary treatment process, secondary, and tertiary. So initially what we have learned is basically like physical process, chemical process, biological process, based on nature of the process involved for removal of the pollutants. Here we are saying that where those processes will be utilized and based on water quality is expected, it can be divided into three, like primary, secondary, and tertiary. Primary, basically initial stages, like its purpose is to remove the floating matter, suspended, suitable solids, excessive oil and grease, like that. So these are called primary treatment process, followed by secondary, which is also known as biological process, which I have explained the various process: aerobic and aerobic, facultative or anoxic. So all those processes falls under the group of secondary treatment process, which are known as the biological process, which effectively essentially removes the colloidal and soluble organic matter from the water. Next comes the tertiary, also known as advanced process. This removes it again. Tertiary, when this tertiary stage you will use, it removes concentration of residual impurities. Means after primary, secondary, still there will be some residual impurities. So depending on the water quality which we are expecting or want, so this residual concentration has to be removed, and those processes are called tertiary treatment process or advanced. Now I am giving you the example. This is not the exclusive list, just a list. Primary is basically for treatment purpose, like screening, Their equipment is called bar screen, grit removal. Grit means small stones. These are called some technology is called grit chamber, comminutor, oil and grease removal, oil and grease trap, and there are a lot of in oil and grease removal. There are a lot of technological advancement called API separator, like American Petroleum Institute separator, TPI separator. Uh, so various advancement also taking place, but ultimately it removes the oil and grease, excess oil and grease from the effluent. Flotation, equalization, those are the various uh, technology or process you can say which is required for treatment of the effluent before it goes to the next secondary process, that is biological treatment. Then sedimentation, gravitational settling, various types of gravitational settling, various configurations available, design, rectangular, horizontal flow, circular radial flow, vertical flow, various. Then sludge removal system. These are all can be grouped into as a primary treatment process. Primary treatment. Now, just I'm showing you some photographs like how it looks like bar screen, equalization tank, primary clarifier. Clarifier or settling, it is the co-terminus when it is used for another. Now, let me explain secondary biological treatment, and this is most commonly used is activated sludge process. Very simplistic term how it looks like after the primary treatment, water flows into the biological system, biological treatment system. So first step is aeration tank. Again, aeration tank, lot of configuration like circular tank, rectangular tank, and aeration tank means it requires air to be supplied. It various surface aeration system. How we will supply the air oxygen into the effluent. As you know, these microorganisms which requires oxygen, as I have mentioned, aerobic system, which require oxygen. And once it is polluted with organic matter, so oxygen is depleted. Oxygen is depleted in the water. Water is free from oxygen. That is the reason why we need to inject oxygen into the water. How you will do it? You do the aeration into the water, so oxygen will diffuse into the water. So it has again various technologies involved into the. It is called surface aeration, diffused aeration. Lot many variations, improvisations are there. How to inject or how to improve the oxygen concentration, dissolved oxygen, as you know. In my last session, I was explaining dissolved oxygen. So how to maintain the dissolved oxygen so that microorganisms will take the oxygen and they will oxidize the organic matter and consume it and convert into CO2, H2 and other gases. So it first is aeration tank. It has a lot supply of air, lot of instrumentation equipment is there. Then this effluent will flow into the secondary settler. This effluent will have a microorganisms in suspension in water. So this secondary settling tank or secondary clarifier, it will help to settle out those microorganisms at the bottom in the form of a sludge. That sludge, which is nothing but a concentrated group of microorganisms, it will again recycled back to the aeration tank. You need to have this enough microorganisms which will eat away the pollutant. So it has to be recycled back to the aeration tank and excess sludge has to be removed. Again, there are various techniques, process involved how to handle this sludge. Simply filter press. Filter press again has a lot of technological variations. Plate and frame filter press, other various kinds of filter press or centrifuge. How to handle those sludge. Next is effluent, which is again will be further treated, disinfected, so that it can be used or disposed suitably, used, recycled or disposed suitably. Again, excess sludge, again it can be treated in an aerobic process to convert into your gas, biogas, methane. But this looks like a very simple, but it could be made into it is a treatment system which has lot of equipment, pump, instrumentation is involved. So if you look at it, typically there are various designs, configurations are available. These are called secondary clarifier or secondary settling tank. Uses circular, rectangular, left side top, which is nothing but the diffused aeration, which is done at the bottom. This one, activated sludge system aeration tank, I was explaining, and this is the settling chamber, circular, and very at the bottom sludge removal system is there, and water will flow from here, and it will be collected for further treatment. And obviously further treatment before you want to reuse and recycle. Now comes the tertiary treatment. Tertiary treatment basically removes the residual pollutants. It can, all these pollutants could be anything, starting from suspended solids, BOD, plant nutrients, dissolved solids, toxic substances. Then it has various methods, means involved coagulation, filtration, adsorption, ion exchange process, reverse osmosis, ammonia stripping, nitrification, denitrification. Then multi-effect evaporator, forward osmosis, electrocoagulation, scale band. These are the various technologies. So I will spend some time on these multi-effect forward osmosis, electrocoagulation, scale band, those processes. But these are basically grouped as tertiary or advanced treatment. Then water wastewater treatment system application. Just I'm giving you some example. Like if you want to remove suspended solids, so these are the unit operations or unit processes involved. Like suspended solids, biodegradable organics, volatile organics, air stripping. Before I just move forward, just 1 minute, just I need 1 minute. Sorry. So let me resume again. Suspended solids, which these are the unit process or operations like screening, grit removal, sedimentation, filtration, flotation, coagulation, sedimentation. These, any of those processes are used to remove the suspended solid. Then biological organics, like as I mentioned, like activated sludge process, all gamut of biological process can remove the biodegradable organics. Volatile organics, it requires air stripping, carbon adsorption, pathogens, chlorination, ozonation, UV, ultraviolet radiation can remove pathogens. And refractory means which are difficult to remove, non-biodegradable organics, carbon adsorption, chemical oxidation, which are required for treatment of this kind of refractory organics. For example, pesticides. If wastewater water is contaminated with pesticides, then we need to adopt these technologies: carbon adsorption, chemical oxidation. Heavy metals is chemical precipitation, ion exchange. Dissolved organic solids, which is technology involved is ion exchange, reverse osmosis, electrolysis, and then nitrogen and phosphorus removal, biological nutrient removal. So these are the just quite an exhaustive list of treatment methods depending on the pollutant. Then, as I mentioned, this biological process or even chemical process, which is a primary treatment, these generate sludge. So those sludge again need to be treated in a environmentally sound manner. So it requires sludge pumping, sludge blending, storage. Then thickening, we need to do thickening, which is nothing but gravitational and flotation techniques. Stabilization, lime stabilization, anaerobic digestion, composting. Then conditioning, sludge conditioning, chemical conditioning, heat treatment, dewatering. Dewatering can happen through plate and flame filter press, as I mentioned earlier. Back belt filter process, centrifuge, sludge drying beds. Very simple and low cost option is sludge drying bed. Then final disposal, landfill, incineration. Even if it is not contaminated with any heavy metals, then those sludge can be used as a manure also. This sludge, if not contaminated with MAA. Nowadays, even co-processing can happen in cement industry because it has some calorific value. So, case-to-case basis, we need to devise a system to find the final solution. Now, before moving ahead, these are the basically overall processes involved in treatment of water and wastewater. Now, depending on what kind of water, I mean raw water, it could be a raw water, it could be a raw wastewater, and depending on what we are going to do with the final water, what is the purpose, quality, accordingly we need to design the system, treatment system. Treatment system again is a combination of all those processes and methods. Now let me move to a few specific technologies. Reverse osmosis and forward osmosis. Here, I should not say it is a very emerging technology or a new technology. As you know, reverse osmosis is there, age-old technology. However, a lot of advancement is taking place in this area on the membrane. Membrane technology. I think you have you had a session, exclusive session on membrane technology for wastewater application. And reverse osmosis. It is nothing but the natural process, natural osmosis that is utilized to reverse way. So let me explain first. The natural osmosis, which is nothing but the direct osmosis, nowadays even it is termed as forward osmosis. It uses low pressure. It does not require high pressure. if you see the diagram, it's a membrane. Solvent passes through the membrane. It is the driving force is difference between the solute concentration, say salt concentration between the two sides. So solvent will flow from, say, solvent is water, salt is the solute. So solvent will flow, like water will flow from high concentration to the low concentration, and once the equilibrium is reached, then there won't be any flow of solvent. Equilibrium is reached means in both the side, left hand side and right hand side, you will have the same salt concentration or solute concentration. And this is the membrane. Now, reverse osmosis, and it happens naturally. Now, reverse osmosis, this is reversed by applying, by overcoming the osmotic pressure. This we have learned in school days also. This osmotic pressure is overcome by applying the pressure. So uses a high pressure larger than the osmotic pressure in the higher concentration side, so that you reverse it. Higher concentration side, you put the pressure which is more than the osmotic pressure, and so that solvent will flow from higher concentration to lower concentration, and you will get the pure water or pure solvent. And this membrane which divides water from contaminants. So here solvent will flow from high solute concentration to low solute concentration. That's why it is called reverse osmosis, and it is called the forward or natural process. Now, this I will spend some time on forward osmosis. Now, forward osmosis application is getting, though it is a natural simplex process, however, so far it has not found any much of application in water treatment. So it is getting popular, and it is membrane technology is getting much more advanced, and it is finding in industrial use for water treatment, wastewater treatment especially. It uses semi-permeable membrane and natural energy of osmotic pressure to separate water from dissolved solutes. Osmotic pressure is used to transport water through the membrane while retaining the dissolved solutes in the other side. It is a very effective separation technology. Separation of salt from the water ensures that only pure water is extracted from the feed solution, and useful for several types of industrial wastewater treatment applications like wastewater treatment, and even in industry for product concentration and water recycling purpose. So, and it relies on energy of osmotic pressure, thereby it requires less energy, and it is a less energy intensive method compared to other hydraulic pressure based water treatment technology. Means compared to reverse osmosis, it is much more energy efficient, and it requires very less energy compared to reverse osmosis. And reverse osmosis is quite energy intensive method compared to the forward osmosis. And I can share my own experience in big industries, even in pesticides manufacturing industry, where wastewater is very much polluted and contaminated with salts. There it is extensively used in India, and it is very, very promising, this forward osmosis application. And lot of technological advancement is happening, and research is happening in developing the membranes, and it is giving lot of opportunity for water recycling and reuse. Now let me move forward to one more technology. This is quite emerging technology and breakthrough technology. It is called scale band. As you know, when water flows through pipeline, some scale deposits. Scale is nothing but the calcium magnesium salts which gets precipitated into the pipeline, say mild steel pipeline, so it gets precipitated. So scale ban, especially in industrial application, even for commercial applications, say you have a multi-complex air condition, multi-complex centrally air conditions, you have a cooling tower. That cooling tower water, like pipeline, scale formation takes place, and in heat exchanger it reduces the efficiency of the entire heat exchange system. So this scale ban is very effective technology which prevents the scale formation, and it is latest technology. It is a non-chemical. Very advantages, significant advantages, non-chemical water treatment equipment and a small pipeline of say 1 meter, and design in such a way with metal ions assembled on a core of sintering method, and simply it is using the galvanic principle what we have learned in our chemistry, school days chemistry, galvanic principle. Same principle is used here, and it converts this calcium magnesium salts precipitates into very small particles in the process, and it gets carried away, washed away by the flow of water. And this is a very effective alternative to conventional scale removal methods like water softening, chemical treatment. Water softening, chemical treatment, these are all chemical based scale removal technology, but this is non-chemical based, very effective, and no energy is required. It is just simply placed in or put in line with the water flow. And in India, these manufacturers are available. One more emerging or new technology is electrocoagulation. We have learned coagulation, flocculation in wastewater treatment, but this is a quite different but very effective, and it removes multiple pollutants simultaneously, like removes suspended solids, heavy metals, emulsified oil, especially oil removal, oil water separation. It removes emulsified oil, bacteria, and other contaminants. How it works basically, water passes through the electrolytic cell, multiple reactions takes place simultaneously, and first metal ion is basically driven into water, and on the surface of the cathode, water is hydrolyzed into, as you know, hydrogen and OH groups. Meanwhile, electrons flow freely to destabilize the surface charge and suspended solids and emulsified oil. So it is basically a typically electrolytic process, and it effectively removes oil and grease, suspended solids, heavy metals, bacteria, and others. And it has basically entire process. I will, in the subsequent slide, I will show you how it works. Basically, it has 3 steps involved. Dissolution, which is in the first step, I am saying the reaction taking place through electrolytic reaction. Then coagulation takes place. Then flocculation. Coagulation, dissolve metal, suspended solids or emulsified oil, they stick into each other. In flocculation stage, those particles become much more bigger by combining with each other, which is nothing but the flocculation. So it has 3 steps involved in this electrocoagulation process: dissolution, coagulation, and flocculation. And as you know, as size becomes bigger, particles combine with each other, it settles by gravity at the bottom and removed as a sludge. And just this is one example how oil removal takes place. Emulsified oil is separated from water through electrocoagulation process. In oil and gas industry, it is quite effectively used and giving the very good results. Typically, system is like this. At the end of the process, like after calculation, obviously it has it is integrated into the other unit treatment processes like settling and sludge removal, filtration, all those things. So I mean here is, you see, one unit, one technology is not enough. It is a combination of technologies or methods which will give you the ultimate result. This is in nutshell the overview of all treatment technologies and few emerging technologies. And I'm not talking about the multi-effect evaporator. Multi-effect evaporator, it is extensively used in industry. It's not a new technology or nothing. It is extensively used in industries for industrial application, wastewater treatment, and there it is more of a heat exchanger application, and it separates solids, dissolved solids, uh, or both organic and inorganic from the system, from the wastewater. Now I will leave this to all participants. If you have any questions, I would try to answer you. So leave it to you for next 10 minutes for discussion.
Participants, if you have any questions, please you can unmute yourself or you can even type in the chat box. We request you to come forward and ask anything you wish to, sir. Let's have an interaction. So Bera sir is a field expert. He has been having extensive experience in this environmental sustainability systems. Even if you have any other doubt other than the topic which has been taken by sir, you can always have it cleared by him. Please, I request the participants to come forward and ask any questions. You can even type in the chat box.
Again, I would say subject is so big, means 2 hours or 1.5 hours is nothing basically. Even we want to discuss very simply, say microbiology, it requires maybe 5-7 lectures to understand the microbiology itself. So again, wastewater treatment technology, primary. So it itself is a in semester, maybe wastewater will be taught in 2 semesters, 2 or 3 semesters. So what I have tried is to just to capture, gives a very glimpse of it. One has to enter into much more detail. Subject is so big and very much multidisciplinary. It requires microbiology, then mechanical engineering, civil engineering, instrumentation, a lot of filtration, membrane technology. Lot many institutions are doing research in membrane itself, membrane application for wastewater. So subject is so big, one person cannot to justify. It's just I'm giving you the areas where everybody need to learn. Means there is no end to it. Means in a lifetime one cannot say that I have learned everything. It is not possible.
Absolutely, sir. It is not possible to summarize such a huge information into 1 or 1.5 hours. That was not possible at all. And it was really nice the way you have brought forward the concepts that are to be thought of, that really need to be looked on. So I cannot see any questions raised off as of now, sir. And I definitely hope that the participants would have got the idea of the basic issues that are to be addressed and that have been brought forward by sir very prominently and clearly. So on behalf of the Civil Engineering Department at IPS Academy, Institute of Engineering and Science, Indore, I thank Bera sir for accepting our request, for being humble and kind enough to take out time from his busy schedule and enlighten us over these important issues. Thank you so much, sir.
It's my pleasure. Thank you. It's really pleasure to interact with you all. And last, the least, I would say what I have tried to project is basically problem-solving approach. How to approach a problem. That's it. Once we know once we learn how to approach a problem, how to solve a problem, then you can pull together a lot many expertise from all disciplines and execute a project. Problem solving approach I have tried to, then basically that's it. Thank you. Nice to
Very, thank you, sir. Thank you for the wonderful session. So participants, we are now heading towards the last session of this short-term training program that will be taken by Dr. Ratnakumar Mutliar. In 5 minutes, he will be joining us, and he will be trying to give you a real-time view of a specific location that has to be dealt of. Let's see, we'll have a new aspect of the things which he is trying to incorporate. So I'll be seeing you in 5 minutes for the last session. That will be followed by the valedictory, and then you will have the quiz to attempt. And as already mentioned, that you need to clear this quiz with at least 60% marks to be eligible for the certificates. So I'll be seeing you in 5 minutes for the last session of the training program. Thank you. So till we get at the location, can I introduce you, sir?
Just a moment.
Okay, so let me know when we can start.
ये शूट है ये प्रॉब्लम है इसको कैसे घुमाना ही समझा नहीं मुझे घूम नहीं रहा है इसमें अभी
जो एडिटिंग का कुछ सॉफ्टवेयर होगा ना उसमें
नहीं है उसको तो डाउनलोड करने में टाइम लग रहा है इंटरनेट ही बहुत स्लो चल रहा है यहाँ पर
तो दूसरा मीडिया प्लेयर नहीं सर उसमें दूसरा मीडिया प्लेयर वीएलसी
है लेकिन वीएलसी मीडिया प्लेयर में वो चल नहीं रहा है वो जो कंपेटेबिलिटी है ना
So participants are requested to wait till we get a connectivity with our expert for this session. Please have some patience. We will shortly get connected with him.
I think we can start now. The connectivity is very going to become very very poor at site because I don't know. Uh, Actually, this is one of the most interior place of India where like it's very close to one of the Indian border in northeast. So in the eastern part of India, there is very weak network. Again, there is a issues of like climate and temperatures also getting falling down like anything. But still, we'll hope we will can go through all this and I will try to show a few of the real time glimpses of the sites. Yes, ma'am.
So shall we start, sir?
Yeah, ma'am, please.
So I'm thankful to Dr. Ratnakumar Mudhyar sir for enlightening us over the real time issues on this sixth day and the last session for AICT sponsored 1 week online short-term training program on water quality complication, restoration and environmental conservation of existing water bodies, Module 2. Ratnakumar Mudhyar sir is the Director of Indian Environmental Consultancy and Research Services, Nagpur. He is an approved EIA coordinator and functional area expert accredited by the NABEC Quality Council of India, ZQCI assessor. He is a postgraduate and PhD with qualifications like IOSH, NEBOSH, groundwater modeling, groundwater vistas, DIS, IIPM, and so on. He has also been an HSE consultant, Green Energy and Environment Services at Doha, Qatar. In all, more than 17 years of professional expertise in EIA, environmental management, and consultancy services. He's also worked as an environmental manager at CHD Power Plant, JSW Energy, DNV Oil and Gas Sector, Sahara Prime City. I also worked as a project scientist at NEERI, Nagpur. I thank you so much, sir, on behalf of the Civil Engineering Department of IPS Academy, Institute of Engineering and Science, Indore, for taking out time from your such a busy schedule and being here with us for the expert talk. Thank you so much, sir. I request you to take over the session, sir. Sir, a bit breaking is in the voice. And as we already know that there is a bit connectivity issue and he's towards the border of the northern part of India. We'll try to make out what is being conveyed to us.
That organizers, that how can I share that? Because that sharing would be a big issue actually here. There is not sharing, permission is not there.
Sir, was it from me or somebody else? Sir, do you want me to share something? Sir, shall I share the content as you say?
Hello.
Yes, sir.
शेयरिंग का ऑप्शन चाहिए उसमें, शेयरिंग का ऑप्शन. हेलो दिनांशी मैडम.
सर मैंने आई हैव एक्टिवेटेड यू टू शेयर द कंटेंट. आपका वो शेयरिंग ऑप्शन आ रहा है स्क्रीन पर? सर अगर आपने ब्राउजर से खोला है तो ये वर्क नहीं करेगा. यू नीड टू डाउनलोड माइक्रोसॉफ्ट टीम्स. If it is open in the browser, you cannot share content, sir.
अरे वो मुझे शेयरिंग का ऑप्शन देना उसमें. हाँ. नहीं, एमएसडीएम का ऑप्शन तो आ गया है, बट उससे वो कनेक्टिविटी लेने के बाद वो दिखाने इट्स नॉट अलाउइंग मी टू गो देयर. अच्छा, इज इट? ओके ओके, जस्ट अ मिनट. Just a second. This speaker. That I got it. वो फर्स्ट टाइम मेरे को नहीं आ रहा था. नाउ इट इज कमिंग. ओपन शेयर. वो पहले वो there was no other icon. It is was allowed to share or show anything. It was totally blocked. Now it is actually allowing me. Include system audio. हाँ. स्क्रीन शेयर हो रहा है कुछ? Is it so? Sharing some issue. Account share. Morning. This is a plant site where the waste comes from various places of the different wards in one of the Nagar Parishad. All this waste has to be get segregated now, and nowadays till date.
We have Dr. Ratnakumar Mudliar with us today. He is on a specific location site which he wanted us to visit, and I have a few glimpses of that particular location. He will be telling us the details of that. I hope my screen is visible.
Yeah. See, this is actually one of the site where actually the complete scenario, you can say, the waste management site has been proposed very recently, and nowadays, since last independence, we India didn't even thought about. Madam, can you just make a bigger one?
Should I zoom it? Now it's clear, sir?
So in that case, we never thought we can do all this in a bigger way, and because we lost almost like a 2, 4, 5 decades to make the things established. Today, what exactly the point or the topic I took taken on board to discuss or to engage all of us is there are a lot of discussions that only keep on going across the various boards and various committees, but actually no one is doing the real time scenario which is actually required, जो कि required है in terms of what you can say uh, implementation on site. So it is expected what we can do much more better. This is the site actually. You can see the complete site boundary is there. Now further, if you can see more, the site is completely encircled with the boundary wall, but there are some power transmission towers are also installed within the site, which is not expected to be done. Agar as it was been approved very recently, so already the power transmission towers have been installed in the previously long back. But now the concept of waste management and site waste management is came into the this picture. So it becomes like wherever they are getting the place, they are doing that job. So hope it will get done soon, and it will be uh, successfully run across the different places. Next. One more big issue what we are facing in various places, they are nothing but कि like वहाँ पे अधिकतर जगह पे the what you can say ponds or natural water bodies are surrounded, which is not expected to be done. So in that case, it is not advisable to make the sites in such place where natural water bodies are going to get harmed. So these are the common site selection criteria which has to be taken care during the site selection of specifically for the waste management site. Next. यहाँ पे भी देख सकते हैं there is a lot of water and few means the localites are trying to do some fishing activities also in the same pond, which may become lethal in coming years. In case if fishing activities been done by the local people in the same pond, in case disaster or in terms of some any leakages of the leachates been transferred to the from the solid waste management site to these nearby ponds attached to this waste management site, it becomes disaster and it going to get contaminate the food web chain. Completely food cycle is get contaminated and all those toxics will be get transferred to the human health. It will become very big risky part for all of us. So in terms of legal as well as in terms of occupational health safety, one has to be taken care in terms of all these management systems. Next. Yeah. Just we can try to get connect with them. Just a second. On site. वहाँ पे share करने की option. I think you need to give the place.
So now I think it should be activated. Is the sharing option coming, sir? So what Ratna Kumar Mudaliar sir is trying to give you a view of the actual location where he has been there to in order to do some mitigation plans regarding some water contamination, some solid waste management as well.
Madam, can you see the screen, please?
No, sir, there is no screen visible as of now.
स्क्रीन शेयर नहीं हुआ क्या?
नहीं सर, स्क्रीन शेयर नहीं हुआ है अभी.
अच्छा है.
Is the screen share?
कॉर्नर में जाना.
स्क्रीन शेयर ऑप्शन आ रहा है सर आपके पास?
हाँ, वो ऑलरेडी शेयरिंग में दिखा रहा है यहाँ से. मीन्स हम लोग साइट जो दिखाना चाह रहे हो साइट दिख रही है यहाँ पे हमको. बट आई डोंट नो.
So some voice is coming, but we cannot see the screen.
सर वहाँ पे स्क्रीन में दिख रही है. I think we need to cut down this because साइट का बहुत दिक्कत हो रहा है.
Sir, if you permit me, I'll share that matter that you have given me, and then we can get directly into discussion what should be done.
Can you see the screen now? Can you see the screen now?
No, sir.
Or you can share the last presentation.
Sir, there is something trying to be displayed on the screen, but it is not visible.
I think the connectivity is very poor here.
So, sir, we'll do one thing, that whatever content you have shared, I'll just play it on. Should I, sir?
Yeah, I request, can you just share the presentation what you already had with you?
Yes, sir. I have now 3-4 small short videos. Should
Yeah,
I
and
start it?
the last presentation, what I shared in module 1.
Yes, sir. Yes, I can get that. Sir, shall I start with the video sharing?
Yeah.
I'm sorry, I had some connectivity issue at my end also. I hope my screen is visible.
Yeah, your screen is visible.
Solid waste management site. We are going to now enter solid waste management site, an integrated waste management site. This is a pond adjacent to the site, which is not appropriate. Just see the compound wall of the project management site, and it's just hardly a stone throw away. Just see the compound wall of the project management site, and it's just hardly a stone throw away site where a lot of villagers have been habiting. They are dwelling in this whole area across the project site, which could be a disaster for as well life threatening. So it has to be done. This is an approach towards one more a pond adjacent to the site of solid waste integrated waste management site, and it also has a lot of water. It's a rain catchment area probably of the whole area, and this water has been used for various purpose, for domestic as well as for cattle. Again, this could be one of the threat for such kind of project. If leachate is not been treated properly, this may going to harm and make big issue. A very good thick plantation has been done, which is very much required, but there is a village adjacent to this hardly 50 meters, which is also not advisable and not sitting in the siting criteria of Ministry of Environment, Forest and Climate Change. So the distance of area living habitat, it must be more than 200 meters minimum, so as to avoid the vectors, flies and disease flying from the waste management site to the nearby habitation.
So that was what I has had from sir. Sir, should I share the PowerPoint presentation now?
Yeah.
I hope my screen is visible.
Yeah, screen is very much visible. And just can you go to the last? One slide. That's it. Innovations. Wait. Next.
Yeah. This
Yeah.
one, sir?
See all. Yeah, that's one. This water, whatever we have been treating across the various time, they have been either used for recreational purposes or either we are using for green belt. Here, it's a very new concept. We are creating a recreational ponds along with using the same pond for generating a green energy. This is solar boats, solar houseboat. Next. Next line, madam. Hello. 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 Your screen, your presentation was missing.
There was some connectivity issue at my end. We are all depending upon technology now. Yes, sir. Sorry.
No problem. Next slide. Coming to the very important slides in this, go to the next slide. Next slide. Next one. Next one. These are very well known. Next. Yeah. Next one again. Yeah. After this, next one. The most important slide is going to come now. See, this is the very unique depiction of the e-waste. What the early one, what it was shown. There are two main segments. Actually, India is lagging. The big wave. Next, next one. Yeah, ready for what we are ready to be ready for what we need to be ready for a coming big wave of waste which are going to already we are facing municipal solid waste. A similar kind of huge problem we are going to face very soon in coming 5 to 10 years at the max. At the moment, we all are now facing in different places, starting from Delhi to Kanyakumari, Assam to Gujarat. But now it is also reached to the foothills of Himalaya. Recently, in last 7 days back, I was with the Himalayan region where we are doing a project for waste management, integrated waste management project, which was not expected. But we found various electronic waste also lying across the Ladakh region as well as in the most northern part of the India, northern eastern part of India, and also in some Uttarakhand near to Chinese border, hardly 200 kilometers from their LAC. It means we are polluting our environment in various forms continuously. We are going for tourism purpose. from various parts of the continent and across the globe to the Ladakh, as well as Badrinath, Kedarnath, as well as some more higher Everest locations. But we are leaving all those electronic gadgets, for example, batteries. आपकी बैटरी खत्म हो जाती है, we just throw it out somewhere. We don't even think about that. We found almost a bag full of batteries, discarded batteries of pencil cell batteries, small batteries, and few of the pieces of like mobile batteries, even some dongles. We found few of the used thrown phones of that quadruped mobiles, and apart from that, some used material of some plastics and all this, which are very common across the near main continent, mainland. So these we are going to see this big huge problem in coming days. So what we need to remediate this, we can plan it very well. For this, there are regulations, but still we are not practicing or not thinking about this coming danger. It is going to become very havoc for us. Already this problem has been categorized and think of by the developed countries. For example, I think most of you people are very learned people, and we must be already knowing the most of the products of big brands like Dell, HP. I'm very responsibly taking the names of these big brands. Even there are some brands, Dell, HP, as well as like many more are there. So those brands usually they are taking those they are taking all their waste through their procedures of buyback. But after buying back, they are dumping all those e-waste, electronic waste, to the developing nations. Out of the audience, can you just anyone help me? Is I'm audible to you? Because ma'am is not there in the link. Divakar
Yes,
Singh ji?
sir.
Yeah. Thank you. So that is one of the major issue we are going to face. And while buying these such kind of articles, we should see, are they certified by buyback policies? Are they standing with the electronic waste utilization certificates by European Unions, CEU? Again, there is one more policy in August 2012 was passed, or but still it is not ratified by most of the countries. But in that case, उसमें ये है कि the waste what we are receiving, or what are the amount we are generating or dumping somewhere, it has to be tracked and disposed of properly at par requirement of the overall European Union, and they have been certified. Otherwise, it generates a conflict of interest material. CIE, they have been certified in that category, CIE, and those waste are dumped into the places like developing countries. The major developing countries which are the hub for such kind of dumping of this waste are India. Biggest is China. Second is India. Third is Thailand, Pakistan, Bangladesh. These are the nearby countries. The major are the China, India. These are the major countries. And who are supplying this waste? The supplier of the waste is major is Australia, US, and Europe. They are dumping all their e-waste, electronic waste, and gadgets to these countries, which are having huge, innumerable quantity of precious metal in that. Due to that, it is generating a conflict between the various countries for buying those kind of material. But though can recycle it, but it generates a threat in terms of it is also terms of what you can say, it's a type of money. It's a has a huge commercial value, so it generates a conflict between the small other countries to buy it, because buying those material, they can generate a very valuable precious metals out of that, extract it, which can lead to, because buying a waste is not a very cheaper one, and in replacement of that they buy the guns. Most of the such disturbed countries or disturbed land across the continent, they are doing, they are dealing with the such kind of waste for passing on. They are buying, for example, uh, Libya or such kind of Algeria, very interior. There are some groups those are buying such kind of waste from developed countries, developed nations, and they sell it to India in return to the what guns and some kind of ammunitions for their what are the militancy what they want to do it. So those kind of things also be now ratified by most of the big countries and big brands, Dell, HP, or Panasonic, and there are many more. So they are make sure whatever the waste they are generating and they are dumping to the developing nations for recycling and refurbishing, it is certified, tracked, and recycled. Right? Next. So this is already under the policies under process. This is one of the major thing what we will be discussing here. As you have seen, we already become very late in the development of waste management across India. Means sorry, and but we have to accept it. We are already late in development of waste management facilities and technologies in India by self or Make in India movement. Almost like we are lagging 30 to 35 years than the other countries, specifically to the almost developed countries. And as compared to the developed nations like US, Germany, UK, we are almost 50 to 60 years back behind them. So we need to have technologies which are very useful, but that too economical for our country. For example, we can see there is a robotic. I think all of you must have been known very much. Whatever the waste we are putting out from our home, they are mostly unsegregated. वो छटा हुआ वेस्ट नहीं होता. We just dump sanitary pads, the polythene bags, the vegetable, the food waste, the paper, the cardboard, the batteries, everything together in one box and just give it to the waste collector. Or in some places, I accept people segregated, they divide the dry and wet waste, but still that is not very, very clearly defined. Again, it becomes chaos when it comes to the site for segregation and separation and sorting. So sorting, it becomes a very major issue. वो सारा कचरा एक तरफ जाके जमा हो जाता है, it becomes so huge, it pile up in multimeters height in one of the highest height of the country waste management site. Heap has been acquired the height of about more than 50 to 60 meters. Can you? I don't know whether anyone can imagine that height. Means 4 5 story building, like three buildings on each other. इतना ऊंचा, that height, 3 to 4 buildings on each other, piling up. The big waste has been piled up in one of the places near to NCR region. So to clean up that, to make a biomining, we are engaged as per the policy. I'm telling you, as well as per the requirement, the human labor. हम human labor वहाँ पे engage कर रहे हैं. Those who are sorting the big different kind of waste within the process. After trommels are being used, filtering, still we are engaging the humans, which is again a not good idea. So we are already past 2021, and still we are doing the same job since which has to be done past 50 years back. So there is a means generation of robotics we are already going through. So the major demand and the need of the nation and the era is development of the robotics. All robotics based on sensors, it can be generated, can be developed innovatively through our various engineering these colleges. We should go for this kind of technologies, such kind of what you can say internship or क्या बोलते हैं training programs. जो when the engineering student has to make a base station or project, they should make a projects of like this. If you can see the top, one small robot model is there. If it has been programmed to go, yes, this one, right, it can go inside into the heap and it can pick the precious metals. लोहा है, steel है, glass है. Moment it is programmed, it can penetrate the huge heaps together and take it out. It can burrow and get all those metal at one point. So only single, almost a very similar kind of waste will be sorted out automatically. When it put it on the conveyors, again, humans are standing across both the conveyors to pick the various kind of waste. जैसे conveyor belt पे waste जाता है, then the people are standing on the sides adjacent to it, and we pick it, big wood logs, metals, glass, etc., which is not means expected to be done in 2021. In 2021 में भी we are doing the same job. It is like I don't know what to call like this. What situation we are going through? Means we are sleep means one of the opinion or the means comment made by Supreme Court in 2012 कि India is tending towards 20th century, going beyond that and having a future vision of 2030, and still we are engaging the humans in picking the waste, sorting the waste, which is very, very inhuman. I again quote, it is very inhuman to engage the human to sorting and picking the waste, which is very inhuman in 20th century, and it is really means very, one has to very think very carefully. Why can't we engage such kind of robotics in our country? Such kind of robotics are already available across the various globes, but either they are not sharing, or if it is even they are sharing, it is not economically viable for our projects. For all the Nagar Panchayat, Nagar Parishad, municipal corporations, those who want to do such kind of small projects of 50 tons, 100 tons, those projects cost not more than 10 crores, 20 crores, and all these robotic systems, their sensors, it costs huge. And apart from that, the development of such kind of robotics in engineering colleges are highly, it is missing. We are, most of the people are thinking about going, working with an ISRO, satellites, but this is also one of the major area where we are lagging. If our engineering colleges can focus, our professors, our students can start doing the projects on this majorly, I think in coming, because it is already too much late, already बहुत late हो गया है, so we have to ramp up very fast in next not more than 3 years. If we cannot put up all this thing in place, I don't know where will be we, where will the India will be. Already the Bharat Swachhata mission is already going on, and in the consequence of this Bharat Swachhata mission, it was a very positive moment. But a big consequence, what we as an advisor came with the new problem कि सारा कचरा तो जमा हो गया, now it is piled up and there is no technology. Means came with one problem solution and landed to a new problem. So this is a very, very major portion, the area thrust, where we need to think it immediately and very, very fast. Thank you. If you have any questions or discussions, you can come with that. I'm open for that, because I'm really sorry I couldn't able to make you move around this site, because there's a very, very least connectivity with the system, because we already arranged everything, but the connection here is very, very weak.
Sir, can you please tell at what location you are right now?
We are in the place, it is near to international border. The border location I cannot disclose, sorry, but the location is very close to the Bangladesh. Bangladesh is from here hardly 1.3 hours away. मैं 1 घंटा 35 मिनट यहाँ से, if I start drive my car, I will reach into the Bangladesh directly, crossing all the borders.
So what's the issue over there, sir?
There are the issues we are facing, like there are border issues are there. Again, there's a human trafficking. There's a big issue in waste management. In terms of waste management, government is dealing mainly some what you can say, the border migrants, the other nationals, they are entering in the name of XYZ labor jobs, and they get settled. This is one big major issue. And once they get settled, they stop doing that job for which they came actually to for in the picture. And again, the waste problem remains as it is. And apart from that, they generate more waste. And the people, those are migrating from nearby Asian countries, They are mostly uncivilized or unaware or uneducated, illiterate people, and that is creating more big hurdles into this means what you can say these border areas. And secondly, the funding. As we should work in India, state and the central government team as a team, one team in Team India. Here across the India, we are means sorry to say, but we are not working as a Team India. There is the project has to be done in 2016 and 17 has to be completed. But till date, when Ministry of Environment, Forest and Climate Change, as a empaneled experts, they asked us कि boss इसका क्या हुआ? Why didn't it was applied on site? We went and we verified कि नहीं, this is not possible because due to lot of different reasons. The labor issue is there, number one, big issue. Secondly, people are those who have been settled at the site. Those who are settled on the site, now they are not allowing to use the adjacent lands of those gram panchayats for this kind of projects. So this is a new issue. And again, the third, the most important issue is finance. If as an engineering college or the professors, everyone very well aware, if the project has been projected or designed in 2016 or 15, almost 5-6 years back, with the cost of rupees like 100 crores, and after 5 years, if it I try to think and develop the same project with the same cost, it's impossible. Almost in 5 years, the cost get escalated very much, and such projects get failed. So these are the major
So,
issues. These are
so what's the reason you are called on for in that location?
actually we just came to settle down the issues. What could be the best technologies can be implemented because time is already been shortened. समय बहुत कम बच गया है. The project has to be completed due to the order of the highest courts and the requirement of the Nagar Parishas, and the technologies what are available across the continent of India. They are not economically viable or to sell off or to establish and function this waste management side easily. So I
Uh,
actually can may I know, madam, how many the professors or the student professors are there in this the
So we
plant
have
for
around
scientists?
26 participants.
Not now. I am asking how many professors were there since day one.
So we have
Accumulated total.
yes, sir. In all we have around 100 participants.
100 professors,
No,
teachers.
some are field experts, some are mostly faculties, but some are from the field as well. Those who are working as practicing engineers also.
Okay, okay, okay. Actually, this kind of means responsibility not to be shouldered by the technology development like IITs or IPS Academy, who can generate such kind of cheaper technology.
So
Because
what
there
has
are
been
some
brought
Asian
forward to
countries.
us is that there is a need to integrate this artificial intelligence and neural networks into this waste management because
Yes.
including human resources is again a threat. Ultimately, they get infected and they face a lot of health issues once they come in contact with the waste. So the best option would be that if we integrate some robotics and artificial intelligence and some neural networks into it, then that might in some way help us to deal with this waste problem. Now, so waste is now not only the form of solid, but we have the liquid waste as well, water, like the wastewater that is being generated. Is that an issue also in the location which you are?
No, actually, the management of liquid waste management, there are several technologies also came. Today only I was just listening about DVX Vortex technology. That is also one of the good technology. Even apart from that, one more new technology came recently, which is Japanese company patented technology. That technology, for example, conventional MDVR, what is seems to be very advanced technology across the India, even across the globe. That MDBR technology, if it cost operation and maintenance cost, for example, around for 1 KLD, let's assume 2 lakh rupees per year. The Japanese technology which came recently, Yokosuka, I think many of you, if you have anyone have been heard about this. This Yokosuka technology cost per year not more than 25 to 35,000 only. जहाँ एक जगह 2 लाख रुपए खर्च होते हैं, this technology comes with 25 to 35,000 only. Secondly, very big major issue of human labor or the human interface is very less. Interference of the human is very less, least.
So the Japanese technology which you are discussing about, is it for solid waste?
No, it is for liquid waste. And it is notified and gazette notification has been already published by Jal Jeevan Mission by Govt of India.
Okay, it is being published.
Yeah, because one has to recognize the technology and certify the technology came from outside the continent, outside the India. It is dependable and it is useful. Someone has to certify. The CPCB and MOEF, they give such kind of authorities with two various departments. So Jal Jeevan Mission under MOEF is also, they publish this. So these technologies have been used across various locations of Ganga clean missions as well as some STPs, small STPs even. And very best part of this technology is it can be installed even like the desk, the teachers, आपके घर में जो table होता है teacher का table, the students table जो होता है 4x6 का, even the smaller than that, a small 1 to 1.5 kg STP can be installed in a small area, and the only it needs is what, power. That's it. And secondly, there's no like external water pump is there. कोई pumping बाहर से कुछ नहीं चाहिए उसको. We just connect the inlet wastewater and take clean water from outside, just like RO. हम लोग जो aquaguard घर में लगाते हैं, it is same and as simple as that.
Okay, now as mentioned by sir, now we have a smaller version of the sewage treatment plants that has been brought forward by the Japanese technology that is economical as well as it is efficiently treating without much power consumption. Is that right, sir?
Not power on. Yeah, total operation maintenance cost is almost 75 to 80% lesser than the existing one. It is competing all the technologies across the whole India. No technologies we must compare with all the technologies. What are the technologies? You must have been heard till today. It is most cheapest and most reliable. Secondly, उसमें कोई आपको अलग you need to make big civil foundations बनाना पड़ रहा है. You need to dig it big holes, making big building construction, बहुत civil का material लग रहे हैं. There is nothing required. Just order it, call them. They will parcel the big unit, just like big syntax tanks of 5,000. अपने में एक जो what you can say, the big multi-story buildings having a water storage tank of 5,000 liters. It is must be almost equivalent of the same size. You can install anywhere on your rooftop. You can underground, anywhere in the place, whatever you have, you can just install, connect the pipes and get the clean water. And it connect your all your sewage line, grey waters, and you get the clean water.
Sir, can the water is classified into grey and black. The black water can also be recycled with that?
Absolutely. All grey and black, both the things are usually, only the thing is you need to collect a sufficient backup raw water. आपके पास raw water backup में होना चाहिए, for which you need to have a backup wastewater to be collected in a sump for air feeding into the unit, because unit has to be fed continuously with standard flow rate. That flow rate has to be optimized and standardized, so it can be feed it continuously.
Right, sir. So that was a wonderful on-site view regarding how a particular location is facing a lot of challenges for not only the solid waste management but also the other aspects that need to be taken care of. So, social and economic issues are also one more challenge which we face while implementation of the projects in a particular location that has been brought forward by Dr. Ratna Kumar Muthiar sir. So if the participants are having any questions, I would invite
Yeah,
them.
the last thing only I want to add to this discussion is there are good projects which funds are available with us. If any such kind of innovative students are there, engineering students are there, we can support those in terms of development of sensors and robotics for management of waste, specifically solid waste management. Thank you.
So if we have any students or participants who are willing to work in this field of solid waste management regarding artificial intelligence and robotics, you are most welcome to contact Dr. Radnakumar Mudliar sir. He is having funds and resources that can help you out with these types of projects. So there's a question in the chat box that how can we treat e-waste?
Yeah, at the moment the e-waste has been collected, disassemble and segregate, they sort it out based on the components. The chipsets are separated, the precious metal components are separated, and the plastic or the FRP and that other material are been separated out. And based on that, they extract those material by making into small bits, the pieces, and extract by amalgamating or by dissolving all the set of plastic and polymers, separate out and extract the precious metal.
So only the recycling is the best option, that is for e-waste, because they are made up of a lot of precious metals that can be used, reused rather, recycled and reused.
In terms of carbon emission, as India is having a target around net zero emission by 2050 or 2070. So in that terms, what I suggest, it's an established fact again, using refurbished material or using a precious metal for development of electronics gadgets or what are the metals we have been using. If you use it from the same resource of the recycled material, it generates 85 to 65% of the carbon less carbon emission compared to the virgin material. Right.
So even recycling the metals will also help in reducing the carbon emissions.
Absolutely, because when we extract or explore the natural minerals from the earth or from any other sector even, that generates a huge carbon emissions in a lot of different activities. It's a totally different subject of circular economy as well as sustainable development, which can be discussed some other time, but it's a established fact. Like means 80 to 65% almost, 80 to 60% mota mota, it is there. It is an established fact.
So thank you so much, sir, for the lovely session and response. And I thank the participants for being present here with us today. So that brings us to the valedictory part of this particular short-term training program. I would like to thank Dr. Ratnakumar Mudliar sir for taking out time from his such a busy schedule, and although being towards the northern border of India, he was willing to participate in this short-term training program. Although he wanted to show a visual of actual further details, but because of network connectivity issue, we could not make to that point. But at least we hope that some idea would have gone to the participants that the real scenario, how it is and how it's a challenge for the different types of projects to be implemented, not only regarding the waste management, but also regarding the environmental conservation and mitigation issues. So that's a big challenge that simply applying to the projects and getting approval is not the only thing. Once you go to the site, once you visit the location, then only you're able to understand what further challenges are there regarding implementation of that particular aspect. So thank you so much, sir, for being here, and I request you to please stay with us during the valedictory session, sir. So that
Thank
was
you.
the. So please be with us for a few more minutes. So that brings us to the final part of this short-term training program. With this, we have reached the end of this short-term training program, which was of 6 days. The journey with everyone was wonderful and amazing. We started with day 1, session 1 by Professor Bhanu Prakash Velanki, Associate Professor in Environmental Engineering at IIT Roorkee. He spoke on the restoration of Dal Lake, Srinagar and Shadra Drain, Delhi. On day 1, the second session was taken by Mr. Akshay Dilip Shende, who is a scientist at NEAST, Kerala. He enlightened us on sewage treatment scenario in India. He also gave us a view about what were the past practices, present, and the future scenario. On the third session of day 1, that was taken by Anuja Bansod Kadhu ma'am. She is the director of Unique NVK Private Limited, Pune. She spoke on the overview of current practices in secondary treatment of sewage. The fourth session of day 1 was a discussion on NEP 2020 by Dr. Devanshi Jagwani, Associate Professor at Civil Engineering Department of IPS Academy. On day 2, first session was taken by Saurja Ghosh ma'am. She is a Principal Scientist and Associate Professor in Engineering Science at the Academy of Scientific and Innovative Research. Also, she is working at the Central Glass and Ceramic Research Institute, Kolkata. She discussed on ceramic membrane-based technology for sustainable treatment of water and industrial wastewater. This second session on day 2 was followed on restoration of lakes and water bodies, field experiences by Dr. Nitin Goyal, Principal Scientist and Head CSIR NEERI, Mumbai. The third session was on protecting groundwater from contamination and approaches for mitigation of groundwater quality issues by Dr. Sudhindra Mohan Sharma, who is the National Nodal Officer, also working upon National Drinking Water Security Pilot Projects at Govt of India. He also discussed 3 practical Indian case studies. The last session on second day was by Professor Srinivas Carey. He was the director of the Center for Urban Governance, Environment, Energy and Infrastructure Development at the Administrative Staff College of India. He spoke on fecal sludge management practices in Hyderabad to protect water bodies and environment. The next day, that was day 3, first session was taken on advanced technology for water management by Dr. M. Silvabalan, who is a scientist and head of Hydraulic Instrumentation and Canal Automation Division, Central Water Power Research Station, Khadakwasla, Pune. He enlightened us regarding multidisciplinary approach for water resources management and that artificial intelligence and neural networks should be included for future water systems management. The second session on day 3 was on trends in biological wastewater treatment, challenges and opportunities by Mr. N.K. Kutiyappan, who is the proprietor of LBK Enviro Consultants. He is also impaneled with NABET, IRQS and Environmental Training Institute, Chennai. The day 3 session 3 on hybrid treatment systems for the remediation of volatile organic sulfurous compounds and dyes containing wastewater by Dr. Balendu Shekhargiri. He is a senior postdoctoral researcher at Indian Institute of Technology, Guwahati. The last session on day 3 was on water bodies, restoration and environmental conservation, Kerala perspective by Mr. Suresh Kuttappan, who is engineer at Kerala Water Authority, Kottayam, Kerala. Fourth day, first session was on Integrated Water Resources Management by Dr. Mahesh Kumar Jat, Head of the Civil Engineering Department, Malviya National Institute of Technology, Jaipur. Second session on day 4 was on Nutrients and Trace Metal Contamination in Freshwater Wetlands of Bihar by Dr. Rajesh Kumar Ranjan sir. He is an assistant professor at the Central University of South Bihar. He focused on studies related to wetlands in Bihar. The fourth day, session 3 was on Quantifying Water, Real and Virtual by Dr. Anshul Pranay Gujarati, who is a director at Eco Solutions Pune. She had more than 21 years of professional expertise and was kind enough to enlighten us regarding practical aspects of water reduction in green buildings, and she also discussed some practical case studies. The fourth session on day 4 was on water body rejuvenation, a nature-based approach by Rohini Pradeep ma'am, who is a project manager at CDD Society, Bangalore. She discussed the case studies of Mahadevpura Lake Rejuvenation in Bangalore and Coimbatore 8 Lakes Rejuvenation, on which she worked. On day 5th, first session was on microplastics in urban water bodies by Dr. Ratish Menon, Associate Professor at the Department of Civil Engineering, School of Energy and Technology, Karukutti, Cochin. He discussed his work on microplastics in topsoil and sediments from Cochin. Fifth day session 2 was on nature-based solution for urban water management by Dr. Manoj Chaturvedi, Chartered Environmentalist, MIEMA, GSAS, CGP, and Environmental Sustainability Manager at Metito, Doha, Qatar. Fifth day session 3 was a participant suggestion and an interactive session. We had valuable views and opinions by the participants. The fourth session on the same day was on quality of restoration of contaminated lands and the related environmental impacts by Dr. Subramaniam. He is the head of the department and senior lecturer of Environment, Health and Safety, Malaysia, retired professor in environmental health, Mahasa University, and EHS consultant from Malaysia. And today the final day was first session on continuous treatability of oily wastewater from locomotive wash facilities by electrocoagulation by Scientist Sravanth Tangellamudi, sir. He is the scientist at NIST, Kerala. Second session was taken on sewage and wastewater treatment for water circular economy, real experiences by Mr. Harshit Sharma, the managing partner and R&D executives at the MLK Waste Management, Bhopal. Third session was on water and wastewater treatment technologies, recycle and reuse by Mr. Dilip K. Bera, sir, the environmental sustainability profession at Karen Energy Limited. And now the final session was taken by Dr. Ratnakumar Mudliar, sir, the Director of Indian Environment Consultancy and Research Services, Nagpur. He was kind enough to let us a view of the actual location on which he was there for a project and the regarding details of which were discussed. Usually such projects are not to be disclosed, but he was humble and kind enough to let us a view, rather an overview of the actual field challenges that are to be faced while implementation of such waste management projects. And now I request Dr. Amit Sharma, sir, Head of the Civil Engineering Department and Dean R&D at IPS Academy, Institute of Engineering Sciences, Indore, to address the participants with his motivating words.
Thank you very much, madam. Good afternoon to one and all, respected Mudliar sir, faculty members, and dear participants. On behalf of Civil Staff family, I would like to congratulate the participants for making this choice and effort to acquire knowledge on water quality restoration of water bodies. Congratulations to the ongoing team, convener Dr. Jagwani madam and co-convener Mr. Lalite Sinha for successful conduction of program. The connection that we have made here will last a lifetime, and I hope this is not the end but just the beginning. When you leave here today, celebrate that you have accomplished, but look forward with an eye towards how you can utilize the knowledge gained from this program and can be inspiration for others and helpful to the society. I hope we will continue to provide support and encouragement for each other in future endeavors too. Thank you very much.
Thank you so much, sir, for the motivating words. And now I'm very thankful to AICTE for sponsoring us to conduct this short-term training program. I'm also thankful to our President, Architect Achal Chaudhary, sir, Principal of IPS Academy, IES, Institute of Engineering and Sciences, Dr. Archana Kirti Chaudhary, ma'am, our Head of the Department, Dr. Amit Sharma, sir, for providing all the facilities to conduct the short-term training program. I'm very thankful to my co-convener, Mr. Lalitesh Sinha, for the support that he has provided, and I'm missing him because of some unfortunate event. He couldn't be here today. Mr. Pratyush Motwani for their support. Special thanks to A.G. Kothari sir and Dr. Kirti Chaudhary sir, Dean Students Welfare, for motivating and boosting us throughout the short-term training program. I'm very thankful, especially to the eminent experts for sharing their work and experience with all of us. I'm also thankful to all the faculties and staff of Civil Engineering Department for their cooperation. And finally, to all the participants, without them, it is not possible to conduct this short-term training program. Finally, to all those people who are directly and indirectly involved in the conduction of this STTP, all the visible and invisible powers that have helped us achieve this. I thank everyone and everything from the bottom of my heart. And one thought is coming to my mind: unless you try to do something beyond what you have already mastered, you will never grow. That was by Ronald E. Osborne. That we have to keep extending our limits every now and then in order to be growing. And I hope and pray that this is not the end, but the beginning of the bond between all of us. And this SCTP will open the gates of new research in the field of water resources management, treatment, and environmental restoration of water resources. I would also like to grab this opportunity to introduce you to an AICT FTP on geotechnical earthquake engineering that is to be conducted by IPS Academy from 6th to 10th of December. So I invite the relevant field participants. If you wish, you can join this faculty development program, which is sponsored by AICTE Atal FDP, that will be conducted by IPS Academy from 6th till 10th of December, the coming week. And now I thank you, everyone, all the participants, and especially Dr. Ratnakumar Mudliar sir, for being here with us today. We are deeply indebted and honored by your presence, sir. Thank you so much, and I look forward to see the participants again somewhere in some training program. So the feedback form and the quiz link will be shared in the WhatsApp group just in a few minutes. Thank you so much.